All right, let's go ahead and get started. I think John Kennedy, Deputy Director of the Fish, wanted to make a few remarks after mine, and I seem to have lost him, but if he comes in, we'll fit him in his schedule. So welcome everybody. I think I know most of you. I'm Matt Kaufman. I'm the Director of the Wyoming Co-op Unit. Every year we have an annual meeting, which is one of the requirements of the unit. We get together with our coordinators and basically it's a check-in, sort of reporting on the work that we've been doing and where we're going in the future. So the cooperators, for those of you who don't know, there's a nice little echo here. For those of you who don't know, the co-op unit is, can I turn this off or it won't be recorded? Okay, I'm just going to go forward with the echo. So for those of you who don't know, the cooperators in the co-op are the U.S. Geological Survey, University of Wyoming, Wyoming Game and Fish Department, Wildlife Management Institute, and the U.S. Fish and Wildlife Service. And so those are the formal cooperators that attend coordinating this meeting. Several years ago, we decided to do something different. Typically at the annual meeting, we report out on the project that we're doing, but instead, actually with the suggestion of Joe Margoff, our USPS supervisor, that it was suggested that we have the students present the projects instead. So that's what we've started doing several years ago, and it's worked out really well. I think this kind of serves two purposes. One, it allows folks to hear the projects that we're doing and hear from the students that are doing it. And two, it's great sort of training for the students to be able to interact with some of the managers that are managing the resources that they're studying. So a little bit about how this is going to work. We're going to be moving pretty quickly. We have 20 talks. Each talk about 10 minutes, and we're starting 20 minutes late. So we'll just stay on task with the 10-minute talks, and we'll make up the time, or we'll just spill over. For students presenting, you're going to get kicked off the stage at 9 minutes. So ideally, you speak for 7 minutes, you answer a couple questions for 2 minutes, and then we take you off the stage and get the next one on. So hopefully you've got your talks well timed. And then for those of you asking questions, we'll hold questions. They're short talks. We'll hold questions till the end, and then hopefully have a time for a few questions. Okay, with that, I'm going to introduce John Kennedy, Deputy Director of the Wyoming Game and Fish Department, to say a few words. And John was
all the well, so we're being taped. This is going out right now. Good morning, everyone. So watch that. I just wanted to say a couple of words this morning. Not much, but really just wanted to say good morning. I'm John Kennedy. I'm in our director's office, deputy director. I've been in the director's office for going on 6 years. I was born and raised in Idaho. I went to the University of Idaho and worked on safe routes for Idaho Fish and Game for a couple of years, and then went to South Dakota State University for my master's work and focused on whitetail deer and mule deer in the northern Black Hills of Wyoming and South Dakota, and then went to Arizona game and fish for about 10 years, and up north to Wyoming, which is where I'm going to be for a long time. So welcome. Most of you, I think I've met almost all of you. Those I haven't, I'll try to get to today, and we can talk a little bit. Good seeing everybody. Matt may have mentioned this prior to me coming in, but it goes without saying how important your research is. You are the unit, and all of you are the Wyoming Game Fish Department's research arm. This is it. So your presentations are really, really important. Their work is critical. Your research, if you don't know already, you'll find out that your research influences what this agency does. So very important. For that, we really appreciate what you all do, and we look forward to the presentations. If there's anything I can do to help out today, let me know. And that's it. If we want to introduce a couple of the folks, or everyone, or how do you want to do that? At least Joe and Chris. You want to? Some of the cooperators want to. Joe, you want to introduce yourself, or do you already know everybody?
You guys just have to do your best to ignore it if it is still echoing. Just stay forward. All right, we'll go ahead and get started since we're already running late. Again, if you guys can just key in on me, I'll be warning you as you're running down to a couple minutes toward the end of your talk. I'm Kevin Monteith, research professor with the co-op unit. session. Nutritional benefits of landscape heterogeneity.
Is it going on? Yeah. Okay. Great. There we go. Okay, great. Okay, so today I'm going to talk to you guys about my research, which is a part of the Lyman Incubator Project. And so the Lyman Incubator Project started in 2013 in response to the Lyman Incubator Initiative. And the primary objectives of that project are one, to determine the vaccine regulating population growth, and two, to evaluate the proximity of that population to the nutrition. Now, in the past, I've talked to you about, whoa. Okay. In the past, I've talked to you about my research contributions that I've been conducting on the interventions for the and this has been focused on the effects of human disturbance from energy development on habitat conditions, behavior, and nutrition. But today, I'd like to introduce to you some of the research I'm doing on some of the animals. And this research is focused on identifying habitat characteristics that are nutritional
I would like to thank all of the Wyoming Range Mule Deer funders. And in addition, I have a couple other funders that are supporting my research. And I've worked with a lot of great people, so I'd like to thank all of them as well. And I can take questions. I have looked at that very preliminarily. So the data that I showed you was from 2013. So we do have the 2014 migration data. But at the time that I was doing the analysis, I only had a really small subset of individuals, the ones that have the satellite upload. So it's hard to say for certain, but in 2013, it does appear that the green up was shorter and it was more difficult for deer to track in that year. But that's like a really preliminary result that I didn't want to present because I just didn't have a big enough sample size. Yeah, but I'm definitely going to look into that more. Yes.
I work in capital service, so I'm way off base with
Okay.
so if I'm way off base, then just help me so.
Okay.
But I would think that phenology tracking would be at least, well, I would think it would be a very small part, an evolutionary thing.
Yeah.
Given that we are in a period of really rapid climate change, could your delay actually represent the inability of muleys to show a change evolutionarily? I mean, we're warming at a rate that would only be a couple or three generations and not really long enough to have a strong evolutionary impact on it. So could climate change be part of that?
Absolutely. Yeah, I'm definitely going to look into that. That's going to be my last chapter. But some work that Matt has done and also Kevin, they've looked at how, well, Kevin's looked at flexibility and timing of migration. And to some extent, deer are able to key in on when to start migrating based off of vegetation growth. But some of Matt's work has shown that the benefits of migration in times of severe drought and increased predation are kind of not serving migrants as well as they used to in the past. So that's definitely something that I'm going to look into in the future. So, yeah.
All righty, next up we have Melinda Nelson, a PhD student in my shop. She's going to be talking about the effects of predation on mule deer in the Wyoming range. Can we get a new talk loaded up there? Maybe? Next talk, please. Thank you. And also, presenters, if you can remember, I'm horrible about remembering to do it, but since we're projecting this over YouTube, if you can remember to repeat the question or think about repeating the question when they're asked, that'd be great. So that way everybody knows why you're continuing to talk. So, okay.
Oh, okay. Thanks for the introduction, Kevin. So I've been here about 3 weeks, and I'm already really excited about this project and the fact that it's new to the state of Wyoming. So why don't we get started? So far, Sam and Ellen have already talked a good bit about the research that's currently being conducted on the mule deer herd in the Wyoming range. But given that the research I intend to conduct is also on that specific herd, I thought I'd give you a little bit more information, so you have to bear with me. To begin, as many of you may already know, the mule deer herd in the Wyoming range is one of the largest herds in the country, and coincidentally, it is also one of the most premier locations for mule deer hunting in the country. Not just specific to the mule deer herd in the Wyoming range, across the Intermountain West, mule deer populations have been declining, and I feel like I can speak for most research when I say the causation behind that recent decline is probably speculative at best. So consistent with that and other factors, in 2007, the Wyoming Game and Fish Commission approved the statewide mule deer initiative that, again, Ellen and Sam have talked about. In 2011, the Wyoming Range Mule Deer Initiative was approved, and this was a result of a lengthy public input process. And so designed from that, as well as overarching themes from the statewide objectives, this was designed to be sort of management as a herd-specific scale. Specific to population regulation in the Wyoming Range, a number of factors have been identified to potentially be regulating that population. And current research that's being conducted has begun to address a lot of these specific issues. But one of the main issues that kind of arose as a key point of interest in the public input process, as well as with Game and Fish, was what, if any, impacts predation is having on population regulation. Specific to neonatal survival, it's important to understand factors affecting recruitment because once most individuals in ungulate species reach adulthood, survival is relatively stagnant. And especially concerning recruitment, recruitment can account for very high variation in population increases from year to year. As you can see from this graph on the top right, they have tracked recruitment over about a 35-year period and have found that it has been declining by about 0.6 fawns per year, which amounts to about 20 fawns. And on the left here, we can see fetal rates that we've measured in the Wyoming Range herd. We can see that adult survival and reproductive rates are typically high, with most females being pregnant with twins. But the big question is, what is occurring from parturition to recruitment that is affecting those levels and is essentially hampering recruitment? So with that, we established the following objectives for this study. One, we want to determine survival and cause-specific mortality of neonatal fawns prior to recruitment. Two, we want to assess factors that contribute to the probability and cause of mortality. Some of these factors could include, but would certainly not be limited to, nutritional condition, availability of optimal forage, as well as hiding cover for fawns to evade predation. And finally, we want to use these factors to quantify the effects of maternal nutrition, habitat, and predation on survival, and hopefully identify which is most limiting. Of course, to do this, we've got to get our hands on some animals, so we started that initiative in March of this year, where we captured approximately 70 adult females. Once captured, we measured their nutritional condition. Then we verified that they were pregnant and measured fetal rates. Once we verified pregnancy, we fitted them with a GPS tracking collar and a VIT, or a vaginal implant transmitter. These transmitters essentially are designed to be expelled from the vaginal canal at birth and hopefully will allow us to track right to the birth site and capture fawns literally hours after they're born. Now, this is the moment where I just thought I'd mention that it's my understanding that a cause-specific mortality study with collared individuals is unprecedented in the state of Wyoming, and we really could not have done this without the loads of public support and support from Game and Fish to get this project off the ground. Now, once fawns are collared, they'll be equipped with a 4-hour mortality sensor. So at the identification of a mortality event, we will hopefully be able to recover remains or a kill site and use evidence at the kill site to ascertain a likely cause of death, or I call it fawn CSI. Possible predators that we are going to be possibly encountering are likely black bear, mountain lion, coyote. Less commonly, we may see gray wolf, bobcat, golden eagle, and grizzly bear. We'll also be doing a suite of vegetation sampling, and this will be in an effort to identify previous objectives related to habitat, such as looking at adequate cover for parturition and fawn rearing, as well as assessing what is available nutrition-wise to meet the high demands of lactation. This is the part of the presentation that I like to call disentanglement. This is really going to be a key factor in my research, and this is essentially going to be separating the fact of predation with the effect of predation. Now, this was really dubbed by Paul Arrington, who was the organizer of the first cooperative fish and wildlife research unit in the country. It was in Iowa, and he was actually the protege of Aldo Leopold. So you know, his thing was predation, and what's most important about that is generally predation is natural in a system. It's always going to be there, but what we need to separate in this research is what is the effect that predation is having on our population regulation. So aside from the overarching management implication of looking at the effect of predation on population regulation, we're also hoping to use this research to assess the feasibility of predator control, what areas may it be effective, if it's effective, and also use our vegetation sampling to see if there's ways we could enhance parturition and fauna rearing habitat. So finally, I'd like to acknowledge our partners in funding, specifically the Wyoming Wildlife and Natural Resources Trust. As I mentioned earlier, this project has been in the works for years. It's my understanding that people have been pushing for a while. So without Wyoming Wildlife and Natural Resources Trust and key partners from Game and Fish and other partners, this would not be possible. So again, thank you very much. I'll take questions. Yes, sir.
What information is available over that 35-year period with respect to relative abundance or absolute abundance of different species?
It's my understanding that we don't have great information on predator abundance. That's one of the things that we are discussing with Dan Thompson, who's the large carnivore section supervisor. So, you know, we're just going to do what we can and hopefully kind of put some of that stuff in the mix and see what the story is there. Okay, thank you very much.
Alrighty, next up we have Teal Wyckoff. She's a master's student in Kaufman's lab, and she's going to talk to us about the influence of development on mule deer migrations.
Thank you for that introduction, Kevin, and thank you all for being here. I am going to talk to you today about a portion of my master's work involving the threats to Wyoming's migratory ungulates that are posed by development. Now, development in Wyoming can run the gamut anywhere from rural and suburban development to energy development and the road network that connects all of this. Really what we're looking at here is looking at the level of development that we have now and how that influences mule deer currently in order to be able to predict the future. You know, as our landscapes are continually developed, what might we learn now in order to look at this as that development increases on the landscape? In order to do this, our objective is to evaluate that relationship between the intensity of development and the behavior of migrating mule deer. We have three pieces of this, of how we're looking at this. First off, rate of movement, stopover area and duration. How are animals using their stopover areas, as well as their fidelity to both their migration route as a whole, as well as to their stopover areas. Really what we're getting at here is to understand, are animals able to access forage along their migration routes? What are the functional attributes of those? And how does development alter that ability of animals to use those functional attributes? We have data from 3 study areas that we are looking at. The first of those are migratory mule deer from the Pinedale area. The primary disturbance type up here is residential, a lot of suburban, rural residential development. And then the Atlantic Rim area here, of course, the primary development type is energy development. And then we have data from Platte Valley. And this overall is our most intact of our 3 study areas. There's a little bit of suburban and rural ranchette development, a little bit of energy development, but in comparison, it is relatively intact. So just a little bit of an introduction for how we are looking at this. If we have animals who are moving between seasonal ranges, let's say winter range, up in elevation to a summer range, they move along a movement corridor. They're stopping and foraging in stopover areas. And we are interested in understanding the differences between how animals are using the habitat in the intact portions of their migration route in comparison to how they're using them in the more developed portions of their migration routes. In order to do that, we are breaking routes down into essentially segments. So for comparison, for the purposes of comparison. So we can look at how animals might move or use stopover habitat in intact habitat and compare that for the same animal, season, year for how they're moving through or using habitat in a more developed area. So comparing between the same route. This is just a look at that. We have developed these disturbance levels for the whole, for each of our study areas. We're breaking that down into segments. Some of these might be short, down at 1 kilometer. Others are, let's say, 10 to 20 kilometers long. And we've broken that disturbance down into no development, low, moderate, and high development areas, and comparing between those. In terms of results, just looking at this map here, basically what we're looking at is the small dots indicate animals that are, the animal is moving slowly. The bigger the dot, the faster that animal is moving. So across that development area where it's yellow and red on this map, this animal is moving relatively quickly, and then she slows down in that more intact portion of her habitat. The take home from this result, we found that the longer that route segment is, so the longer the development area that they have to cross, the faster they are moving in comparison to how they move in intact habitat. And we saw this both at moderate and high levels of development. We did not see this response at low levels of development. In terms of stopover use, stopover selection, the take-home message here is we found that animals selected predominantly intact, more intact habitat in comparison to, say, the average of their route as a whole. So for what they have available to them at the route level, they are overall selecting for more intact habitat. We did see a bit of variation in this. That is driven, we think, by two things. One, by disturbance type. There are differences between rural residential development and energy development, and also how quickly that disturbance appears on the landscape. So rural residential may appear more slowly, whereas energy development may appear more quickly. In the graph here, we're looking at data that have been binned by year. And on the y-axis, we're looking at a stopover selection. Everywhere below that dashed line or in the green indicate that animals are selecting for more intact habitat. Results for route fidelity. The take home here is that animals overall did maintain fidelity to their migration routes, but were shifting where they were using stopovers. They're basically selecting for more intact, so they are shifting those stopover areas a bit away from development. Generally, we did see some shifts, major shifts in their migration routes in Atlantic Rim, in the development area where energy development appeared quickly on that landscape. In the maps, what we're looking at here, the map on the right is an example of high fidelity. This is 2 springs and 2 falls worth of data. And so this particular deer is maintaining quite high fidelity to her migration route. The other map with the different colors on it is from Atlantic Rim. And development occurred quickly in the summer while she was on her summer range. And she has tried several different routes to negotiate her way through that developed area when she came back on her fall migration. So what we found here is that although they have relatively high fidelity to those routes, there may be implications here. If deer are maintaining such high fidelity, even as that habitat deteriorates, this may have some biological implications. So summary of these results, first off, we saw an increased rate of movement across longer development lengths. We weren't picking that up at, say, 1 kilometer, but as the length of that development increased, we started to see an increased rate of movement. We saw this at both moderate and high levels of development. Animals are using stopover habitat that are relatively more intact when compared to their full migration route. And animals are maintaining high fidelity to routes, except in rapidly developed areas, but they are shifting their stopovers away from development where they have the opportunity to do so. Management implications. What we hope is that the results from this work will help shed light on what the influence of development is on migratory mule deer. Again, looking at that picture now in order to help predict what the future might hold as development increases on the landscape. Also to provide methods for how we can identify development, both for current infrastructure as well as for predicting future development. And of course, to provide information for the continued management and conservation of the species. And with that, I'd like to thank our funding and data partners, without whom this work would not be possible, and thank all of you for being here. And I'd be happy to take a question if I have time. Thanks.
Are you able to track the level of activity associated with the different types of development, or is that to move it?
You know, their work has been done on that, and I was not able to. I am using all basically data that has already been collected for all of Hall Sawyer and the co-op units work. So I'm basically taking a retrospective look at what is going on. So I'm not able to go back and measure those levels. There are other projects going on who are going to be measuring that currently in current projects. So what I can say is we may be able to use some of those numbers to help inform in a roundabout way what we mean. Because yes, I mean, really what we're looking at here in terms of a development footprint is really the human activity. You know, that's really the metric that we're trying to get at here. Thanks.
All right, now we'll shift out of the mule deer world and talk about elk. Travis Zaffarano, a master's student with Kaufman, is going to come talk to us about monitoring elk migrations with remote photography.
Thank you, Kevin, for that introduction. So Wyoming is known for its wide open spaces, its dramatic mountain ranges, and the broad diversity of wildlife. And this includes a long list of big game species. And these species not only play an essential role in the ecological landscapes in which they live, but they also provide an important source of revenue for local communities and the Wyoming Game and Fish Department. Ecotourism and hunting draw tens of thousands of people to Wyoming every year for an opportunity to catch a glimpse at some of these big game species. To sustain huntable populations of these big game species, it is essential for game and fish biologists to understand and monitor the population trends of the herds they manage. In addition, many of our big game species are migratory. Here we can see the migration routes of the Cody and the Clarks Fork elk herd in the northwest corner of the state. And where the warm colors represent the summer range locations of these animals, and the cooler colors represent where they spend their winters in the lower elevations. And the fall migration is heavily influenced by weather. Cold temperatures and snowfall drive these animals out of the higher elevations and trigger the fall migrations. Now, if we zoom in, we can see that the fall migrations and many of these migration routes transverse many different hunting areas during the harvest season. And this can make it difficult to set harvest limits and season timing for these animals. So increasing the recognition of these fall timing migrations and mediates when and where these animals are available to harvest. Herd composition surveys are conducted annually for our big game species here in Wyoming. They provide essential information on the age and sex ratios of these herds, as well as the recruitment levels, and are useful for herd management. Traditionally, these surveys are conducted via helicopter for bighorn sheep, mule deer, and elk, and by fixed-wing aircraft for pronghorn. These traditional methods of collecting this composition data are very costly, dangerous, and invasive way to collect this herd data. For example, the Cody and Clarks Fork herd annual classification survey costs between $13,000 and $17,000 a year. Recent wildlife highway underpass installations have given researchers a chance to investigate alternative surveying techniques. Hall, Sawyer, and Chad LeBeau in 2011 used remotely triggered cameras to document 10 to 15,000 migrating mule deer through a wildlife underpass near Kemmerer called Nugget Canyon. The high success rate of documenting these migratory herds sparked an interest in whether or not these methods could be used along naturally occurring migratory bottlenecks to collect this composition data. In between 2010 and 2012, the Wyoming Game and Fish Department and the Cooperative Fish and Wildlife Research Unit conducted a pilot study in which they deployed cameras along migratory routes of the Cody herd. And within 2 years, over 6,000 elk were photographed and classified. Several years ago, the co-op unit and the Wyoming Game and Fish Department began discussing the potential of these methods to collect this data. It was decided that a study to evaluate the efficacy and to fine-tune these methods was warranted. So it is my research objectives to investigate the efficacy of this newly proposed research data collection method. First, I will be investigating the feasibility of using remotely triggered cameras at highway crossing structures to investigate the composition of mule deer herds. Secondly, I will also be looking at whether or not this method can be used along naturally occurring bottlenecks to collect the same data for migratory elk herds, for several migratory elk herds in the northwest corner of the state. This will include comparing the data collected with these cameras to traditional aerial composition surveys, as well as determining the location of some of possible long-term monitoring locations. In some of the areas where these elk migrate, geographic features as well as general topographic ruggedness restrict their migrations to specific passes and ridgelines. On this map, the dark red regions highlight kind of some of those hot spots, some of the highly used traffic areas for these animals. Spatial analysis of the elk movements can show us where many of these individuals are funneling through these migratory bottlenecks. And these bottlenecks on the landscape offer the best opportunity to photograph migrating animals as they pass by. Utilizing this tool, in addition to migration routes that were known by Wyoming game biologists and game wardens, has allowed us to deploy 30 trail cameras along the migratory routes of the Cody herd, the Clark's Fork herd, the Wiggins Fork herd, and the Jackson herd. Now you'll notice that on this map, there's no migratory data for the Wiggins Fork herd northwest of DuBois. That is because until this last year, there's been no GPS location data collected for this herd. However, in March of this year, 15 GPS collars were deployed in this herd, in addition to 30 that were deployed last year in the Cody herd. These collars are programmed to take a location and transmit that location every 40 minutes. And this will not only help us highlight the migration routes of these animals, but also lend evidence to where some of these migratory bottlenecks exist on the landscape. So hopefully, we're going to pull up a little animation here of a series of it's not on there. Okay, well, I had an animation set up showing some of these individuals as they migrated past one of these migratory bottlenecks. And as these elk pass by the camera, you can clearly identify that this large group is moving in a single direction, directional movement of a large elk herd. And you can clearly identify cows, calves, yearling bulls, and adult bulls, the same composition data that we're looking for these herd management. These data will also contribute to understanding the timing of these migrations for each of the migratory herds. So this graph shows a timeline of different age and sex classes as they migrate past one of these migratory bottlenecks. As you can see, the spring and fall migrations are represented by the peaks in the numbers of animals passing by this migratory bottleneck. And you can also tell the difference in the timing of different sex classes for these individuals. If you look at the November or the fall migration on the left side of the graph, you can see that the large proportion of these bulls don't start migrating until after many of the adult cows, calves, and spikes start their fall migration. We can also get a rough estimate of calf survival and recruitment rates for these herds by comparing the numbers of calves between the spring and fall migrations. Currently, we are collaborating with Wyoming Game and Fish Department to build a central database where these data, the photos, and summary statistics can be shared and archived. So the management implications of this project, if we can determine the location of several of these good monitoring locations for cameras, could develop a network of long-term monitoring stations to gather demographic information for several migratory herds independently. And if the database that is being designed will be a helpful tool in standardizing, archiving, and sharing the information amongst Wyoming Game and Fish officials and other interested constituents. And if the accuracy of these herd composition taken from these cameras is comparable or better than those that are collected via helicopter, it may offer a more cost-effective, safer, and less invasive way to collect this composition data. And with that, I'd like to thank all the collaborators and contributors to this project. Without the Wyoming Game and Fish Department, Doug McWhorter, Greg Anderson, Allison Cordamont, Mark Orsino, and James Hobb for all their logistical support. Also Lee Livingston, an outfitter outside of Cody. Arthur Middleton was collaborating on this project. Also like to thank Native Range Capture Service for helping us get those GPS collars out. Also, funding contributors, the Rocky Mountain Elk Foundation, Wyoming Governor's Big Game License Coalition, and of course the Wyoming Game and Fish Department. And with that, I'll take questions.
Thanks, Travis. All righty, next up we have Brian Lamont, who's working with myself and Kaufman, master student, and he's going to talk to you about the influence of beetle kill on resource selection of elk and hunters and their interactions.
All right, so thank you for your time today. Allow me to talk to you a little bit about my project. So as you're all well aware, in the West, there's been a bark beetle epidemic, and in southern Wyoming and northern Colorado, that's no exception to that, with over 1.5 million hectares of lodgepole pine alone being impacted by the mountain pine beetle. So as a result of this, wildlife biologist Tony Mong, as you can see pictured down here in the left corner, became interested in better understanding how this may influence, this landscape level change may influence the way that he manages his area. And so this project is in the Sierra Madre Range, which is in south central Wyoming, which encompasses hunt units 13, 15, and 21. The Sierra Madre elk herd is an extremely important herd for the state, with some of the highest harvests being recorded in recent years. So if you think about as trees begin to fall as a result of the bark beetle, we're interested in better understanding how this may influence resource selection on elk and hunters. If we think of elk by themselves first, you can think of as canopy decreases because of more trees falling, this is going to take away from thermal and hiding cover from the elk. On the flip side of that, as those trees fall, we'll begin to see more sunlight hitting and more understory growth being produced. And so if we think of the hunter side, if there's more trees that are falling, it's going to be harder to access the forest, which may in turn lead to hunters having a harder time accessing elk. And so then if we kind of combine those two pieces between the hunter and the elk, in the face of beetle kill, how will this beetle kill influence those interactions? With harvest being the only viable control of elk in the Sierra Madre Range, this becomes an important question for managers. If elk numbers increase as a result of hunters not being able to access elk because of the the fallen trees, then this could put a higher demand on forest resources. So this is just one conceptual model, just kind of a scenario to think about when we're thinking about this project. And so if we look at 2012, the brown is representing a patch of conifers and the lines are representing hunter movements going through. Say they're starting at the top and moving down through this patch of conifers. At that period of time, there really weren't that many trees that had fallen, and so movements were fairly easy for the hunters. As we go through time from 2012 out to 2018, there's the possibility that as more trees fall, it's going to be harder for hunters to possibly move through these areas. Now, if we add elk to this, represented by the ovals here, and go through time as well, you can see that elk may also have a similar situation where it's hard for them to move through there, and there may possibly be less interaction between the elk and the hunters. So this is just one possible scenario that we may see moving through time as more trees begin to fall. So this scenario led me to my research questions. Will beetle kill influence elk and hunter resource selection? And will beetle kill influence elk and hunter interactions? So to get at these questions, we began collecting data in 2012. And so between 2012 and 2015, 58 GPS collars have been put out on cow elk. These collars take locations every 45 minutes during the hunting season and every hour and a half outside of the hunting season. This will allow us to see interactions between hunters and elk during the hunting season periods of time. So when you look at this map, it's a little washed out here on the screen, but on the right-hand side, you can see more areas of the gray stages of beetle kill, whereas in the center, there's more stages of the green conifers. And so this particular elk was a collar that we retrieved in 2014. So this was 2 years of data. And just from preliminarily looking at this, it looks like this elk is selecting for areas of less beetle kill. So our second piece of data that we're collecting is from hunters. And so every fall we go out and ask hunters to carry GPS units for us. And hunters have been very cooperative so far and helpful with the project. To date, we have over 300 tracks saved from hunters. Essentially, we give them a supplied GPS unit. They carry it for 1 day of their hunt, and at the end of the day, we retrieve that back and download their movements. So similar to the elk map that I just showed you a minute ago, this is a hunter movement, and his movements represented with the black dots there. You can see that, like a lot of rifle hunters, he stayed to the road a good bit, but when he did get off the road, he seemed to skirt the edges of the beetle kill, and so that's the type of information that we're interested in learning more about. The third piece is the beetle kill layer. The layer that we currently have really isn't fine scale enough for this analysis, and so we're creating, using NAPE imagery, we're creating a new beetle kill layer which will classify the different stages, the red stage, the gray stage, and the green stages. Combining the elk movements, hunter movements, and the beetle kill, this will allow us to create a resource selection model to do our analysis. So ideally, all of this information will contribute towards management. And so from a herd management perspective, ideally, this will help predict changes in hunter effort, if there are any changes. And as I mentioned earlier, harvest is one of the only viable controls for this elk population. And so ideally, we can provide some information that if it's necessary to adjust harvest strategies, Game and Fish could be able to do that to maintain a healthy elk herd. And so the second piece, management-wise, is from a forest management perspective, if hunting does continue, if hunting becomes more difficult for hunters to move through the forest, this may possibly result in an increase in elk numbers, which possibly could put a higher demand on forest resources. And so as the Forest Service is creating timber harvest management plans and travel management plans, ideally they could use this information to help them in their process. Lastly, I'd like to recognize our contributors to this project. Game and Fish, in particular, Tony Mong started this project. He's been instrumental in this project, as well as Kim Olson, which is the game warden in the Bags area. She's been very helpful as well. The Forest Service provided the seed money for this project, which without that, we wouldn't have been able to get this going. And would also like to recognize the Rocky Mountain Elk Foundation, Wyoming Big Game License Coalition, as well as Saratoga and Encampment-Rollins and Little Snake River Conservation Districts. All of these groups have been supportive since the beginning and continue to be supportive throughout. So thank you very much. And if there's any questions. All right. Jerry?
How much of the landscape or study area is there plans to take out of?
So they've been harvesting in there for quite a while.
Small part or is it a big part of it?
I would say it's a small part based on the amount of beetle kill that's in the area. Yeah. All right. Thank you.
Okay, next up, we have Alex May, master student working with Kaufman and myself, and he's going to talk with us about demography of moose and nutritional responses to beetle kill in the Snowy Range.
So thank you for allowing me to continue the death by ungulate ecology progression. So my research focuses on the Snowy Range, which is hunt area encompassed in hunt area 38 in the southern extent of the state. This is a very important herd for the state of Wyoming, in part because all of the governor's tags exist within this region. And it's a relative newcomer, and it's thought to experience the heaviest cow harvest proportional to population. Also, just statewide, moose are very important both for tourism and for hunting, and they're struggling across the southern extent of their range, including southern Wyoming. And though they're very charismatic, there's still a lot of questions that remain about their ecology. So the objectives of my research are twofold. One, is the current harvest strategy sustainable? In the Snowy Range, it's rather difficult to count moose because it's so overrun with conifer timber. And then how is recent beetle kill affecting behavior and fitness? So to accomplish this, I caught personally, just me, no, a large collaborative effort to place 30 GPS collars on moose around Medicine Bow National Forest. They're going to be obtaining a 90-minute fix rate, and they'll be deployed for 2 years. And the cool thing about this project is that we're doing biannual recaptures. So each of these cows that have just been collared will be caught 4 additional times, and during each recapture, we'll be measuring pregnancy and body fat. And these stars here are our capture location. So in the Snowy Range, it's typically characterized by very narrow willow bands and interspersed with large pockets of conifer. And a previous study, which I'll be getting to in a minute, conducted by Philip Vigas a couple of years ago, showed in a resource selection function that conifer is important to these animals. And conifers have been seeing a lot of changes in this range. So it may be difficult to see, but over here on the left, from 2006 to 2014, there's a wholesale change between green timber and red and gray timber, reflecting the massive landscape scale beetle kill epidemic. So one of the cool things we'll be able to do with this project is we can compare movement and behavior data across 2 data sets. So Philip Vigas, in a project that was begun in 2004 and deployed 23 collars in 05 and 06, has an identical fix rate to our project, and we'll be able to compare movement of these moose with movement from 2006 when the forest was very different. Furthermore, we'll be able to compare individual movement strategies and the nutrition component from the project to see how home ranges influence individual habitat selection and fitness. So there's a couple different things that can happen with beetle kill and moose. Most importantly, ultimately the needles and trees fall following beetle kill. And so without beetle kill, typically in a conifer forest, you have an understory that's shaded out with little forb and herbaceous growth. but it's an important thermal refuge for moose in the summertime. And in the winter, the needles help suspend snowpack above the ground, and so moose can use these areas to seek refuge from deep snow, which hopefully we'll see again in the future at some point. But following beetle kill, the overstory opens up significantly. So we may see improved food resources for moose in the summer, reduced utility as a thermal refuge, and in the wintertime, there may be deeper snowpack in those areas. And so this gives us a great opportunity to examine the demographics of this population. So with the fact that we have all cows collared and that we'll be doing these recaptures where we can measure nutritional condition, we can follow calf production relatively closely without having to handle the calves themselves. So we'll be first cued into the existence of these ugly little guys in early December through PSPB, reassessed in March through ultrasound assessment of pregnancy, and then we can recite them in July, late August, and then during the following 2 recaptures of the female. And with the nutritional component, we can answer questions about what's the quality of the range. So if we're not experiencing density dependence in the snowy range yet, we can expect moose to be fat and very productive. Whereas if there is an element of density dependence and the range isn't very good, the moose cows may be skinny like myself and experience poor recruitment. Although since coming to graduate school, I count myself as lucky to have experienced poor recruitment at this point. So these are some naive comparisons. I just wanted to pretend like I was like everyone else with results. But these are just summary statistics from our capture. We did helicopter darting, and 27% of our captures were conducted on private lands. So Game and Fish was hugely crucial to securing those permissions, without which this would have been unsuccessful. But as we can see, we had relatively low percentage of calves at heel compared to the previous study by Philip Bigas and the sublet study from Brendan Oates. And pregnancy rates were comparatively high. Again, I want to stress that these are highly preliminary. They haven't been parameterized by anything whatsoever. But I do want to stress that this is much later in the season. So I'm very curious to see what happens during our December recaptures when we'll be measuring pregnancy via PSPB instead of ultrasound, because in some cases in harsh winter conditions, moose can reabsorb fetuses. And so we may see an even higher pregnancy rate in December. And then lastly, we're just a couple ticks above the 4-year average for the sublet study for ingesta-free body fat. Is that like 3 minutes? Okay, so I'll take any questions if we have time. I do want to thank the Laramie Region Game and Fish personnel for all the logistical support with captures. They're listed in the lower left, and Will Schultz is on the list. He's just behind the icon. All right, thank you. Thanks, Phil.
All right, sticking with moose. Next up, we have Brendan Oates. He's a master's student under the direction of Kaufman, and he's going to talk to us about spatially explicit demography of 2 moose populations with contrasting predator densities. Okay.
All right. Thanks for having me today. Moose haven't always existed in the greater Yellowstone ecosystem, and they actually showed up around the late 1880s, according to accounts from Native Americans. And when they showed up there, they were coexisting with abundant populations of grizzly bears and wolves. And they coexisted for about 40 years until wolves were extirpated in the 1920s and grizzly bears were significantly reduced. So in the absence of these apex predators, habitat became the dominant influence on the demography of these moose. But now, grizzly bears and wolves are recovered in the greater Yellowstone ecosystem. So there's a need to understand the level at which these predators influence the demography of moose in the region. So our research is looking at the effects of habitat, predation, and climate, and how they interact to limit the demography of moose in the southern Greater Yellowstone ecosystem. And this is going to become important as large carnivores continue to recover portions of their range in the Intermountain West. So to answer this question, we have data from two populations. The first is the sublet population, and it's the largest moose herd in Wyoming, and we conducted a study from 2011 and 2014, and they've seen pretty stable calf-cow trends over the past few years. The Jackson population comprises our other data set, and they haven't been so lucky and as far as calf recruitment is concerned. We experienced a pretty precipitous drop since the mid-90s. And part of what we know about that decline is linked to 1988 Yellowstone fires, which burned almost 1 million acres in Yellowstone, or in the greater Yellowstone ecosystem. And research in the 90s showed that shortly after the fires, there was a significant decline of moose in the region. And we also know from previous research by the Kaufman Lab that these fires reduced the forage quality in the home ranges of these moose, of these Jackson moose. And that combined with the effects of drought have had a negative effect on the demography. But we still don't understand the relative influence of apex predators on this population. So over the past 2 decades, we've watched grizzly bears and wolf populations increase steadily throughout the northern half of the greater Yellowstone ecosystem. And this map shows grizzly bear density. And as you move from north up here, and this is collar data from the Jackson population. This is collar data from the sublet population. And as you move from north to south, you can see a pretty striking gradient of decreasing grizzly bear density. And the same goes for wolves as well. They exist in much higher numbers up in the Jackson region than they do down in sublet. So with this high to low predator gradient, we're able to take a little bit closer look at how moose are responding to these top-down versus bottom-up factors. So between the two populations, we're looking at 5 vital rates and assessing how they interact with a suite of habitat covariates and predator covariates to essentially figure out how population is responding to these factors. And today I'm just going to focus on neonate survival, which is an important prerequisite to annual calf survival. Neonates are extremely vulnerable during the first month of life on the ground. So it's important to know to what degree neonate survival is contributing to this annual calf recruitment. So the way we do this is in February, when we capture these adult females, we take a blood sample. From the blood sample, we know whether or not they're pregnant. And if they are, we come back in June with a helicopter and observe them from the air to see if they gave birth to a neonate. And then we come back 4 weeks later, mid-July, to see if that calf survived the most vulnerable period of its life. So to get a better sense of how habitat and predation are influencing survival, we're zooming into the home range of each individual collared moose. So for example, this is a moose from the Jackson region. This is her summer home range up by Yellowstone. And within that polygon, she's experiencing different metrics of forage productivity, which we measured using NDVI metrics, grizzly bear density, wolf density. A portion of her home range may have burned in the 88 fires. And she's also experiencing different levels of winter severity measured with snow water equivalent and summer precipitation. So by assessing all these covariates at the home range scale, we're able to get a little bit better picture of and capture that all that variation as far as what is actually influencing the habitat conditions for these moose, while at the same time accounting for the density of predators that each individual moose is experiencing. So we went through 64 mixed effects logistic regression models to assess the top model. I'm just going to take you through that top model and the 3 variables that were most important. So to start off, the length of the growing season from the previous summer had a significant positive effect on survival. So as the length of the growing season increases, this is Julian day on the x-axis, survival increased. And this is one of those bottom-up factors of habitat that's influencing survival. But we also found that the proportion of home range that was severely burned had a negative impact on survival. And so it's the greater proportion of burned home range, lower survival, and this was slightly more important than the length of the growing season. This, again, another bottom-up forcing factor. And the most important variable in the top model ended up being grizzly bear density. So as density increases, neonate survival decreases. And this covariate ended up being 1.5 times more important than the burned home ranges. So this is a good example of how top-down forcing is an important factor for neonate survival. So really what's going on here is an interaction between predation and habitat. And yeah, we figured out that grizzly bears are an important predator of neonates, and we actually expect this given all the research that's been done up in Alaska and northern Canada. Wolves were not a significant influence on neonate survival, but they still may come out as an important predictor in annual calf survival or in adult survival. And so yeah, grizzly bears were more important than these bottom-up factors of habitat. But it's important to remember that the magnitude of the habitat variables that each female experiences can differentially affect her susceptibility to a predation event. So we still have more work to do, and we're about to test the rest of these vital rates using a similar framework that we did for neonate survival. And we're also going to do some simulation models and manipulate habitat condition and predator density in different directions and magnitudes to see what their influence is on population growth for subwet moose and Jackson moose. And ultimately, what we do here is to provide good information for you all, the managers, so you can make more effective management decisions. So in the future, we'll have some more good information regarding moose demography for those decisions. And I just want to thank Scott Smith and Commissioner Price, Gary Freilich. We're all very helpful with the Subwet Moose project. We had Sarah Dewey, Steve Kane, Doug Smith, Dan Staler, Mike Jimenez. They all provided a lot of good wolf data for our analysis. And Gary Hamby from the Bridger Teton National Forest has been a great collaborator and supporter. And with that, I'll take any questions.
Neonate mortality decline. Observing calf that heal initially and not subsequently.
Correct.
So how did you account for potential losses before your initial cycle?
That's a great question. So that's one of the drawbacks of how we did our calf surveys. So the question was, how do you account for calves that were potentially missed from before the first survey was conducted? So we're actually going to get at that because we have GPS collar data. We're doing it's basically a movement rate analysis to see when and where these female moose actually gave birth based on a movement model. So we'll be able to look at the results from that analysis and see to what degree are we missing calves from these aerial surveys. All right. Yep.
All right, rounding out the ungulate session, we have Jared Merkel, who's a postdoc working with Kaufman. He's going to talk to us about predicting brucellosis transmission risk using phenology-based movement models of elk. And if I recall from the dry run of his talk, he promises to give a remedy as well. So we'll see if that's okay.
We're going to solve all the problems of the world here. So 10 years ago, I was driving down the road in Arizona, and I was working for the Mexican Wolf Reintroduction Project, and I snapped this photo of an elk and a cow feeding at, or drinking at the same water hole. And obviously then I had no idea that it would be so useful now. So it's kind of cool. Anyway, so I'm working on the brucellosis issue, and I'm not going to go too much into depth, but obviously it has huge implications for the livestock industry oh, cool. Okay, that. Excellent, or has big implications for the livestock industry in Wyoming, but I'll touch on a couple of the most important things. It's a bacteria, and when female elk, bison, or cattle become infected by the bacteria, they will abort their very first calf. Then they can keep the bacteria within their body the rest of the year. They just have no, or the rest of their life, they just have no symptoms. The other most important thing, and you'll see this for this research, is how it's transmitted. And it can be transmitted simply by an infected female that aborts their calf. If another animal comes in contact or sniffs that calf, it can become infected by the bacteria. And so that transmission event is super important for reducing brucellosis risk. So there's lots of management options. There's test and slaughter. Wyoming Game and Fish has worked on that. There's some vaccines that they're trying, some biobullets that are shot at elk. But a lot of these aren't completely viable and don't fix the problem 100%, and they also are quite costly. And so a lot of what we do is work on commingling risk and trying to keep cattle and elk away from each other, especially during that transmission period. And so my research really is looking at what are the factors that influence commingling risk. So how does it work? So from the elk perspective, we basically do things to try to keep elk away from cattle. We do have habitat enhancements, burning, etc. Then we have supplemental feeding, which we do in western Wyoming, try to keep elk from moving down into areas where there are cattle. From the livestock perspective, we can adjust livestock turnout dates on public lands to try to keep cattle away from areas where elk are potentially migrating through or in the area. But what we need for that second part is our understanding of elk habitat use and where elk are at certain time periods. And so what information do we really need to assess this risk and where this commingling risk is on the landscape? The first thing is really important is the temporal dynamics of when that transmission period occurred. And Dr. Paul Cross from USGS and Wyoming Game and Fish, Brandon Skurlock, they did this huge study on using bit transmitters, and we've pinned down pretty well where the peak abortion period is, and that's from about March 1st until the end of May. So during that 3-month period is when the abortions happen. So now we know what time period to focus on. The other information we need is the distribution of seroprevalence. So some areas have more brucellosis than others. Then we have elk density. So these two pieces of the puzzle we have pretty good knowledge of because of Wyoming Game and Fish Department. And then the final piece is understanding the spatial dynamics of elk habitat use, and this is a little bit less well known. So that's where my study comes in. So the objectives simply are to first quantify how forage conditions, spring green-up, length of spring green-up, which we keep hearing about, and weather, snowpack, how that influences elk movement during that critical transmission period. Once we have an understanding of that, then we can take that information and develop prediction maps of where elk could be at certain times of that brucellosis transmission period. Then we can take those predictions, combine it with that other at-risk information, and develop maps that clearly show where the probability of an abortion event per cell per time period can be. So for my part, what's the methodology? You have lots of GPS collars on elk, or that have already been collected on elk. GPS collars that have collected lots of data on elk already. We're going to take a movement modeling approach where we look at where these elk went, compare it to where they could have gone, and figure out why they chose those areas over others. We can look at that and predict that movement based on a few variables, and these are some of the ones that we will probably use. First is feeding locations. So most of these elk are fed during the late winter, and so they have strong site fidelity to that feeding site. And then obviously at some point feeding ends, that changes the behavior of the elk. And then after that, we have snow depth and green up periods that'll influence the movement of those elk. And so those are the variables that'll help us predict how elk move across the landscape during that critical brucellosis transmission period. Then we can use some fancy modeling techniques to develop these maps that I'm talking about. And this is kind of what it might look like. So this is just elevation of the study area. We have feed grounds in blue. You have Pinedale there, you can see. And I just want to orient you. I'm going to show you a couple other maps just like this of what we might expect. So like I said, we'll have these maps and it'll provide us the risk of brucellosis transmission. We can have, let's imagine high is going to be red, low is going to be yellow. And then for illustrative purposes, we'll just take one slice or one day in time on May 1st, which is actually the date I took that picture at the beginning of the study 10 years ago. So it's kind of fitting. Anyway, so we'll have a gradient of different snowpack, different times that feeding has stopped, potentially how fast the spring greens up. And what we can see is, let's say, for example, if we have a year with very high snowpack, the risk of brucellosis transmission will likely be lower in elevation, and our modeling techniques will provide maps to actually allow us to delineate where those areas are. Then a normal year, that risk of elevation, a normal year of snow, that risk of brucellosis might be a little higher in elevation. And if we have a lower snow year, by May 1st, many of the animals will be farther up their migration to their summer range, and that risk of brucellosis will be much lower where cattle are. So these are the types of things that we can produce from this research, and I can imagine it being quite useful for both livestock and wildlife managers. With that, there's a whole huge project behind this. I'm just a drop in the bucket. And so I'd like to thank everybody that's worked on this project and developed it. So thank you very much.
Yeah, I'm gonna ask another dumb fish question.
It's okay.
Is brucellosis natural to elk, or does it come from the cattle as an exotic species?
Well, it is. The bacteria is not natural to North America.
Okay.
It was brought over. You guys got to correct me if I'm wrong. I'm new to this field. But we just have some recent genetics that show that it's kind of a mess. Cattle have given it to elk back and forth, and so it's not real clear how that works. But yeah.
So why then wouldn't it be just easier to vaccinate? I mean, politics.
Sure. Yeah. I mean, well, I actually don't know exactly, but aren't many of the vaccinations you have to do every year, and they're not always perfect. I think that's part of the main reason. But yeah, that's kind of maybe above my pay grade. Yeah. Okay.
All right, thanks, Derek.
Thanks.
Okay, so I think our original plan was to take a break till 10, but that's only 10 minutes from now. Should we go to 10:10, or do you want to stick? Okay, so we're going to do a 10-minute break. So we'll be back at 10 o'clock, going with the next run. Thanks, everybody.
It was just my box. No, they know. Yeah, we met earlier. Good luck.
Let's go, we're gonna get started.
Okay. I think you all know me, but I'm Anna Shalfoon, and I'll be moderating the next two sessions. I'm the Assistant Unit Leader for Wildlife. Just a couple of reminders for speakers. I'm going to give you a 1-minute warning at 7 minutes to try to get everyone done by 8 to accommodate questions. Again, will you please repeat the questions from the audience for our remote listeners? And as you'll see from the schedule, we're now going to segue from the four-legged hoofed things to, you know, some even more interesting critters. And, and our first speaker is Doug Kynath, who's a doctoral student in Matt Kaufman's lab, and I believe still Dan Doak. And his talk is focused on the sensitivity of Wyoming's species of greatest conservation need to development.
Okay. So I'm going to give you a brief thumbnail sketch of what we call the ALVED project, the Assessment of Wildlife Vulnerability to Energy Development. And the goal of this project was, in the face of all energy development that's occurring, use the available data to assess the species-specific vulnerability to energy development so that we can make some biologically informed management priorities. And specifically what we're talking about is the Wyoming Species of Greatest Conservation Need List. And there are about 156 or so terrestrial vertebrates on that list, of which a large portion of them we have very little information on. And so let me give you a quick idea of what we're talking about when we talk about vulnerability. So vulnerability is really, there's two components to it, exposure and sensitivity. And exposure is, are you where the stressor is, where the threat is? So that's largely a function of the distribution of the species, as well as the distribution of the stressor. But then if you're exposed, are you sensitive? and that is largely a component of the species biology. And if you have those two things together, you're both exposed and sensitive, then you're potentially vulnerable, and that can eventually lead to impacts or even extirpation, local extirpation from areas. So what we decided, or what this project was designed to do, was to calculate quantitatively exposure and sensitivity relative to energy development for all Wyoming species of greatest conservation need. And I should say all terrestrial vertebrate species of greatest conservation need. So amphibians, birds, mammals, and reptiles. Exposure, we calculated as essentially the distribution of the stressor, which in this case was oil and gas development and wind power, which we developed projections out to 2030 for where these would occur in Wyoming. And then we combined that with distribution models, so models of the habitat of all the SGCN throughout the state of Wyoming. In this case, this is an example of all of back pocket mouse. And we calculated exposure for all the SGCN, and we also estimated the uncertainty in that exposure estimate for all the SGCN. And the result was a graph like this, which was the end of my talk at the last meeting. And on the x-axis, you have the exposure index, which ranges from 0 up to 0.3, with higher exposure meaning more of your habitat is coincident with energy development. And on the y-axis, the farther you go up the y-axis, the more uncertain we are in that estimate. And so out in that red area is sort of what we're calling the at-risk species. And you know, just some of the most at-risk species, which I talked about last time, are Wyoming pocket gopher, the Great Plains toad, pygmy rabbit, and that green dot way to the left of the red area is sage grouse, and that was actually turned out to be our 17th most exposed species. So this is what I presented last time. What we've done since then is to actually quantify that sensitivity. And sensitivity is a real sticky issue. And there's been a lot of research on it and not much that's really locally applicable. And so what we decided to do was conduct a meta-analysis. And so we compiled roughly 80 studies from around the world that were on suites of species, about 1,600 species altogether over 3,400 habitat patches. And all of these studies looked something like what you see up here in these pictures, where there were remnant habitats in a matrix of disturbance. And so that could be everything from agriculture in the prairie systems, pasture and harvesting in forested areas, or even energy development in places like Wyoming. But the common denominator here is we had presence and absence in all of these patches across this spectrum of development. And we asked the question, what species traits predicted the rate at which these species went extinct in all these patches? And what we found out, we did a lot of mixed effects modeling and used Bayesian information criterion to select the top model. And the top model that predicted sensitivity, here shown in the red box, was a combination of the habitat type, the class that you're in, so whether you were an amphibian, bird, mammal, or reptile, how specialized you were on that habitat. Were you a generalist? Were you moderately specialized? Were you highly specialized on just a single habitat type? As well as several life history parameters, including body mass, lifespan, and litter size. And more explicitly, what we found was that, so the x-axis here is effect size. And so if you have a positive effect, you're more to the right. That means you're more sensitive, and that's what I've shown here in the black bars. Whereas if you're below, if you're in the negative direction, that means you're less sensitive to disturbance. And so what we found was relative to forest, down in the orange, the grassland species were quite a bit less sensitive. They blinked out less quickly when habitat was removed. Also, shrubland species were less sensitive than forest. Regarding taxonomy, in blue there, the reptiles were by far the most sensitive to habitat disturbance across all these studies, as were in green the highly specialized species. Body mass had a small positive impact, or a small increased your sensitivity somewhat. So by this metric, forest reptiles that are highly specialized and large are going to be your most sensitive species in the landscape, because all of these things are additive and they combine in not straightforward ways depending on what your biology is. So what does that look like when we consider vulnerability? Remember, I said vulnerability is a function of exposure and sensitivity. There's not a really good way to combine the two. And so for now, let's just look at a graph of all the SGCN with exposure on one axis and sensitivity on the other. And what that looks like is something like this. The key is up in the top. The amphibians are the triangles, the birds are the little blue circles, mammals in red, and reptiles are in dimes. That didn't really show up too well on the graph there. But and what on this graph, the farther you are up into the upper right-hand corner, the more vulnerable you are, because you are both exposed to development and you are highly sensitive to that development. And so the species that really stand out, however you combine these metrics, Wyoming pocket gopher comes out on top every time. It is both very exposed to development and it's sensitive to development. And interestingly enough, I always got questions about sage grouse when I gave talks about these in the past. And sage grouse is right there in the middle of the screen. It actually comes out in the top 5 in most of these analyses, because even though it's fairly far down the list on its exposure, it ends up being pretty sensitive to disturbance. So I think that these are the critters that we need to, that managers need to consider as we move forward. And very interestingly, we have a lot of these addressed just in this group right here. Joe is going to talk about, the silky pocket mouse there is one of the high ones. And if you actually follow that line of red dots to the left of that, those are the other pocket mice. So they're also up in that zone. And those three, Anna, those 3 little dots that are grouped just to the south of sage grouse there are the 3 sagebrush obligate birds that are there because most likely because they are their habitat specialists. Their habitat affinity puts them in there. So this is what I think we need to be focused on as we move forward in thinking about these critters and what we need to pay attention to in terms of SGCN in Wyoming. And that's what I had. So thank you to all of the variety of collaborators and funders that helped to put this together. And I can take questions. Okay.
Yeah, I'll ask my competition question. A competition on
Because we didn't have enough money and time. It would be good to do, they're a whole separate realm of modeling. And it just was, it would have been a whole separate project in and of itself. And we had to take one chunk and we took the larger chunk.
On the graph that showed the sensitivity related to different habitat types.
Back further. Excuse me. Yep.
But it appears from the final graph that most or a number of the species that are most vulnerable are grassland species.
And that is, yes, they're less sensitive, but they're also the most exposed because the development is largely in the basin. And so the question, I'm sorry, I forgot to repeat the question. It was why even though shrubland species were less sensitive, did they not show up as being most vulnerable? And those shrubland species that did show up as most vulnerable also had aspects of their biology that increased their sensitivity relative to them being in shrubland, like sage grouse, which are fairly large and they use a lot of landscape, and the pocket mice, which are very habitat specialized and dietary specialized. And so they jump, those aspects of their sensitivity push them up. Cool.
Okay, our next speaker is Jason Carlisle, who's a PhD student in my lab, and he'll be talking about how non-game species fare under the sage grouse umbrella.
Thanks, Anna. All right. So umbrella species concept in conservation fits into this larger family of surrogate species strategies, and I'd love to talk to you more about those if you have any questions, but all of these are appealing in theory because they can serve as shortcuts to help managers like us conserve species that are at risk. And they're very appealing theoretically. There's not a lot of evidence to support them on the ground. But we have a really unique opportunity here in Wyoming with greater sage grouse because there is so much attention focused on greater sage grouse that we can use sort of this real world scenario that we have in Wyoming to see what effect conservation of one species has on other species. And some of those species are some of the same ones that Doug just mentioned here: pygmy rabbits, brewer sparrows, horned lizards, ferruginous hawks. The list goes on. And as Doug mentioned, there's 150 plus species of greatest conservation need identified in our state wildlife action plan. And almost a third of those are associated with sage grouse habitats. And wouldn't it be nice if what we do for grouse could actually benefit these species as well? These other species, I'll call them the background species that might be under the umbrella, they're almost exclusively non-game animals. They receive limited funding and focus. Here's just a little snippet from the SWAP that kind of formalizes the fact that we just don't have the time or attention or the money to devote to each of these species. Now, sage grouse themselves are an SGCN, but they're very different in a few ways that might make them a good umbrella species. First of all, I'll just walk you through each of these. There's a lot more incentive to manage sage grouse, and if you don't know about that in this state, then you're probably not from this state or haven't been here very long. With the Endangered Species Act listing pending, I mean, there's a lot of motivation, there's a lot of things happening. I'm not gonna regale you on that. And I really think that Wyoming has been exemplary in coming out sort of ahead of the game, leading a state strategy to try to conserve sage grouse, which was led by the Office of the Governor and the core area strategy that a lot of other Western states have followed suit with. There's also a lot more money to manage sage grouse, and this is just a snapshot of Game and Fish's expenditures from 2014. You can see we spent $2.5 million on sage grouse conservation, and then those other 4 bars encompass hundreds and hundreds of species that are receiving much less monetary attention. And then lastly, sage grouse are different because there's a very firm regulatory mechanism in place to make sure the conservation is happening on the ground. And here in Wyoming, that's led out by the sage grouse core area policy from the governor's office that started in 2008. And you can think of it as these orange polygons are the core areas of sage grouse where we're focusing most of our conservation. Now the other species, these background species under the umbrella, I mentioned there's a lot of our SGCN that are associated with sage grouse habitats, and this is how they fall out taxonomically. Primarily birds and reptiles, mammals. Sorry for the amphibian people in the room. Gabe, only a couple of those. So the real management question becomes, does sage grouse core area management benefit these other species too? And the research questions that we're addressing are threefold. First of all, we want to find out who's there. Which of these background species might actually fall under the umbrella since we have these core areas drawn out in space. Secondly, how are those species doing? We want to figure out if populations of these SGCN can be viable under the core area umbrella. And then lastly, how does on-the-ground sage grouse management affect these other species? Just to give you an idea of where we're at in this process, we've completed 3 field seasons of research. We have 1 more ahead of us here starting in a month. And fingers crossed, in a year or so, you'll hopefully be hearing some more final results from me. But the first question, who's there? The broadest way we can answer this is using some of this GIS data that Doug has shown you. And this is data or models that Doug and his colleagues at WIND have produced. But first of all, we have a map of core areas where those hollowed out regions are the core areas again. And then this is a map kind of like Doug showed you where the orange areas are the suitable habitat for, I pulled an example here, greater short-horned lizards. And we can do some simple overlay analysis in GIS. And we find that 48% of the suitable habitat for horned lizards is within a core area. And we do that for a whole bunch more species. I can walk you through this in detail later if you want. But it's interesting, we have quite a wide range where there's a handful of species that don't even occur or their suitable habitat doesn't occur in the core areas of sage grouse. And I should mention these are all species that are associated with basin type habitats. So we've already excluded the alpine and montane kind of species. But then we have some species like the Colombian sharp-tailed grouse at the top that has over 60% of its suitable habitat is being protected by the core areas. And you see we have quite a wide range in between. Now these are some results that we're in the works of finalizing. So I'll share some of those findings with you real quick before we move on. And some of the things we found out with that last graph is that the similarity seems to matter. The more similar you are to sage grouse, the more likely you are to benefit under a sage grouse strategy. So birds that like the sagebrush, that require a lot of space, it's intuitive, but it's important for us to understand that there are maybe some limits to this umbrella. Secondly, size of the core areas and that umbrella really matters. We did a little experiment where we said, well, what if the core areas were made a little smaller? What if they were made a little bigger? And found out, how many species we could potentially offer more protection to if we could have made the core areas a little bigger. And then if we would have scaled the core areas down, you can see species falling out from under that umbrella pretty quickly. So the size is a really important attribute of the core areas we have. And I should say at 24% of our state is core area. So this, as it is already a very large size, a Herculean conservation effort. I don't want to belittle that at all. Moving on to the second part of finding out who's there. You can think of this as kind of ground truthing these models. We're doing some surveys in the field in the Lander region. And because Jeffrey City is near and dear to my heart now that I do research there, I'll put it at the center of the map here. If you haven't been there, you should go. Lander's in the top left corner, but the little black dots are the transects that we were surveying inside and outside of core areas for some of these SGCN species. And those are results you'll hear next year from me, hopefully. Figuring out how they're doing, this is a harder question, figuring out which species are doing well under the umbrella. So we've of necessity focused in on some of the sagebrush obligate songbirds that Doug pointed out, maybe not our most vulnerable species, but they're certainly in the upper reach of that. And we're figuring out what these species need out there in the habitat and how much that corresponds with what sage grouse need. The last aspect is concerns on the ground management, because you can understand that if we're committing to protecting really large areas for sage grouse, then of course that's going to benefit the things that also live there. But what if we then go in and start manipulating these habitats to try to make them ideal for sage grouse? What we've done, we've partnered with people at UW and Game and Fish and BLM to do some habitat treatments that were designed to help sage grouse. And we're collecting data on these SGCN species before the treatment, which was in 2013. The treatments were already implemented, and this summer will be our second year post-treatment of monitoring these SGCN populations. And this is just a map of the area near Sweetwater Station. Those yellow areas were mowed to improve sage grouse habitat. So the management implications of all of this, first of all, we can identify for Game and Fish which of our SGCNs may or may not be benefited by the sage grouse conservation strategy. Secondly, we can identify how similar the needs of those species are out in the landscape. And then thirdly, we can help understand what the consequences of managing for sage grouse on the ground might be for some of these other threatened species. Got a lot of people to thank, and our funding primarily comes from Wyoming Game and Fish. We have secured a few other grants and collaborators along the way, but I'll leave it at that, and thank you for your time.
So what demographic rates, I guess, upon those species that you're able to measure with respect to the habitat?
The habitat treatment? Yeah, so we're focusing primarily on abundance and then reproductive success. So we do counts, and then we also monitor nesting, the nesting cycle of these species for productivity. Sure, I'll give you a little tidbit since you asked. So the mowing area, the mowed footprint itself is pretty much total loss of habitat for these sagebrush obligate birds. They don't nest there, they don't seem to really sing there or feed there, but they do seem to sidestep those areas and make a living kind of on the fringes of those treated habitats. So it's not that, it doesn't appear that it's having a really drastic effect on their abundance or demography, but we're digging into the details a little more on that. Gabe.
Sorry about this question.
Oh no.
So if you, you really can't conserve or protect the entire core area. So we're using it, sometimes it's so long towards certain areas within the core area.
Mm-hmm.
Usually one of the most widely protected species or ways to look at that or look at specific areas within that.
Yeah. Yeah, so the question is, could we prioritize areas within the core area that might be the best umbrella? And honestly, that's within our reach, especially with Doug's work. If we can prioritize the species of greatest conservation need that are the most vulnerable, we can kind of prioritize them and find the areas that they need within the core areas, and we could easily do that. But keep in mind, those core areas are managed for grouse. So, I'm the guy on the sidelines saying, hey, think about these other species too, but there is a big need to focus on grouse conservation in those areas. Thanks.
Okay, our next speaker is Joe Ciardini, who's a master's student in my lab, and he'll be talking about cheatgrass and small mammal SGCN, or species of greatest conservation need.
Thank you, Anna. So just as some species are more threatened than others, certain habitats are at a greater risk. And this figure is from a study that assessed habitat conversion and protection in terrestrial biomes around the world. And this shows that for the temperate grassland, savanna, and shrubland biome, 46% of the land has been converted and only 5% is protected. And this is the highest ratio of converted to protected land for any terrestrial biome in the world. So this led the authors to conclude that these habitats are critically endangered. And they're primarily threatened by agriculture, energy development, and invasive plants. So the same factors that threaten these habitats around the world threaten them in Wyoming as well. And in our State Wildlife Action Plan, invasive species are considered a leading wildlife conservation challenge. And this map shows the probability of cheatgrass establishment, and it's based on 2013 and 2014 surveys by Karen Noseworthy, who's a graduate student at UW. And it's important to point out that this doesn't necessarily represent the current distribution of cheatgrass, but just where there's suitable habitat for establishment. So lighter colors are higher probability, with white being 90 to 100% probability of establishment. So based on these predictions, obviously, cheatgrass expansion in the state is a very large concern. So given this context of invasive species in Wyoming, one management challenge we face is understanding how cheatgrass may influence native small mammals. From other work, we do know that small mammal communities have reduced diversity and abundance in areas invaded by cheatgrass, especially for specialists like kangaroo rats and pocket mice. On the other hand, it tends to favor generalist species like deer mice, which often increase in relative abundance. But there's a lot that we don't know about this relationship. For example, we may know what species are where, but we know a lot less about how they're doing in terms of fitness. The mechanisms behind these patterns are poorly understood. And there's little known about the effects to SGCN in the state. And specifically, we are focusing on grassland and shrubland SGCN. And so the focal species are 4 pocket mice and 1 harvest mouse. These species are all primarily SGCN due to a lack of data. We just don't know a lot about them, as Doug mentioned earlier. They're rarely caught in studies, so their abundance is considered rare, but this also may be a result of low detection probabilities for these species. There aren't many current studies delineating important habitat, and again, the effects of invasive plants on these species are not well understood. So why should we focus on small mammals in the first place? Well, they play a diversity of roles in the ecosystem. As most of you know, they've been shown to regulate plant communities through seed dispersal, seed predation, herbivory, soil aeration. And in addition to having direct effects on the plant community, this also may alter habitat quality for other species, such as grazers. And of course, they're an important prey source for other mammals, like the swift fox and raptors and reptiles. So to summarize my research questions, first, how does habitat alteration by cheatgrass influence small mammal populations and communities? Does cheatgrass invasion alter predation risk for small mammals, which will help us better understand the mechanisms behind these patterns? And are SGCN small mammals rare or hard to detect, looking at detection probability? Our field work is already done, and it took place in Thunder Basin National Grassland, which is outlined in black here. See the distribution of grasslands in yellow and shrublets in green throughout the state. And Thunder Basin contains a good mix of native and invasive plants, which allowed us to address our research questions. So first, to look at population and community metrics, we established 16 sites across a gradient of cheatgrass cover from 0 to 75%. We used mark recapture to estimate abundance and survival for species with a lot of data. And then we also looked at occupancy and community diversity. And we looked at powder tracking with to look at habitat selection. And to look at how cheatgrass may alter predation risk, we used a giving up density experiment, which allows you to indirectly assess predation risk with these foraging trials. And this is one of the foraging trays shown here. And then finally, to look at detection probability, all of our sites had a mix of trap types, so we could look at a trap type preference. And then we also modeled detection probability as a function of covariates. I'm going to show some results from question 1 and 3, but I'm not going to show anything regarding the predation risk experiment. So we modeled occupancy for 2 pocket mice species pooled for analysis, silky pocket and olive back pocket, which are fairly similar SGCN. Our top model had cheatgrass, adjacent riparian habitat, and ear. So this plot shows occupancy on the Y and cheatgrass cover on the X. And you can see as cheatgrass cover increases, the probability of occupancy decreases. Although the trend is fairly obvious, it's clear that there's a lot of variability around the estimates, as you can see by the confidence intervals. And then we see the opposite trend when we look at the effect of adjacent riparian habitat. And this is outside of the trapping grid, but within 200 meters of the site. That's why it's adjacent. And so higher levels of this covariate leads to higher probability of occupancy. Again, there's a fair bit of variability, but less so than for cheatgrass. And both of these predictors do have a significant effect on occupancy, but the riparian effect is stronger. So I also mentioned the importance of looking at detection probability, which we modeled as well. And on this plot, we have detection on the Y and percent of moon illuminated on the X. And as we would expect, pocket mice are harder to detect when the moon is brighter, likely due to an increase in predation risk, either real or perceived. And this could have important implications for field studies, such as deciding when to actually trap in relation to moon phase, as well as for what covariates to include in models. So some expected outcomes from this work, an improved understanding of the effect of invasives on SGCNs, informing future field studies, again, by understanding the factors that influence detection probability, and contribute much needed data on these population and community patterns, which will facilitate swap updates. We also will contribute to invasion ecology more generally, looking at how cheatgrass invasion may affect survival for generalist species, deer mice. And then also through our predation risk experiment, getting a more mechanistic understanding of this relationship between cheatgrass and small mammals. And I'd like to thank Game and Fish for funding, and happy to take questions. Yeah.
It seems as if as the habitat changes from native grassland to invasive, you get a more simplified small mammal component. Are you able to look at the density or biomass to determine what the higher trophic level effect would be in that?
Density or biomass of
small mammals.
So the question was whether, as cheatgrass makes the community more homogenized, whether I'm able to look at biomass and how that might affect higher trophic levels, I think. That's not something that we have looked at so far, but I think that we would have the data to do so. because we do have mark recapture data split up by species. So we have abundance estimates either adjusted or not adjusted for detection probability for all species. So it's something we could calculate, yeah. So the question was whether the importance of riparian areas become more important as cheatgrass cover increases. That's a good question. The top model that relationship wasn't explicitly showing an interaction in the sense that the effect would change depending on the effect of cheatgrass, the percentage of cheatgrass. But when you plot both of those variables together, you do see that probability doesn't hit 0%. So as cheatgrass cover increases, probability hits 0% further out when you have more riparian area. So in some sense, yes, what you're saying in terms of it offsetting the effect of cheatgrass, there is some evidence for that. And yeah, it could be a result of a refuge or just some additional habitat heterogeneity, which is allowing those species to persist.
Our next speaker is Ember Hall, and Ember's work centers around Wyoming's quintessential charismatic microvertebrate, the American pika.
Thanks, Anna, and thanks to those of you here at the Wyoming Game and Fish Department for hosting us. As Anna said, I'll be talking today about my dissertation research on pika responses to climate change. Warming climate trends are changing habitats, species distributions, and phenologies across the globe. These changes are causing challenges or presenting challenges for conventional management paradigms. And as a result, climate change is a priority research area for the Department of the Interior, including the U.S. Geological Survey, the National Park Service, and the U.S. Fish and Wildlife Service. Here in Wyoming, climate change is one of 5 conservation challenges identified in the State Wildlife Action Plan. Concern over climate change in Wyoming is well placed. So this figure shows observed trends in the minimum January temperature over the last 12 years. What I want you to note, if I can find my laser pointer, there we go. What I'd like for you to note is that 2 things, especially from this figure. And the first is that climate change is a management challenge that's affecting ecosystems statewide. So areas in this figure that are warming are shown in yellow, orange, and red. The second thing I'd like you to note is that we're seeing a particularly rapid rate of change in that area in the western part of the state where a lot of our high elevation habitat is located. With these observed changes, you can expect that species that are living in these high elevation environments may be particularly sensitive to both changes in temperature and variation in precipitation. And indeed, each of the species here are included as SGCN, either in whole or in part because of concern over climate warming. So one of the first steps towards identifying how we as managers, or how you as managers, I should say, can adjust to climate change or can deal with climate change is to understand how species might be responding to these new dynamics. The American pika offers an excellent study species through which to test wildlife climate change hypotheses. And this is because they have a couple of really useful characteristics. So first, they occupy a relatively narrow thermal niche. They're kind of the Goldilocks of high elevation environments. So they don't do well when surface temperatures are particularly hot, and they don't do well when surface temperatures are particularly cold, especially when that's coupled with low snow cover. They're also active year-round in the alpine, which is a highly variable environment in and of itself. And they occupy relatively undisturbed habitat, which allows us to investigate how climate change may be affecting them without having to worry about things like physical habitat loss. Pikas are also a species of conservation concern. They're ranked as a Tier 2 SGCN here in Wyoming, and they're also monitored in more than 20 Department of Interior management units. So in order to better address how high alpine species or how high elevation species may be responding to climate change, we're pursuing 3 primary research objectives. So the first is to quantify the importance of microrefugia in variable climates. I'm going to come back in a minute to why microrefugia may be particularly important. The second is to assess the demographic consequences of climate variability. Very few studies have been able to do this, particularly with a high elevation mammal. And third is to evaluate whether species can behaviorally buffer climate variability. In a sense, can they use behavior to somehow moderate the rapid changes that they're experiencing? For the purposes of the remainder of this talk, I'm just going to address my first objective. All right, so why microrefugia? Well, microrefugia may be particularly important to high elevation or climate sensitive species because one, it's often readily available to be exploited, and two, it can help to shelter individuals from both climate variability and increasing climate extremes. So we address the research question, how important are microrefugia to the occurrence of temperature-limited species in variable environments? We tested 5 alternative hypotheses to evaluate the relationship between pika occurrence and microrefugia. I'm just going to step through these very quickly here, and in fact, I'm only going to talk about 4 of them. So the first was a local habitat hypothesis, and this said, you know, microrefugia don't really matter. The things that are important are things like forage, slope, elevation, those sorts of things. The second said that surface temperature would be the best predictor of pika occurrence, so what the temperatures are like that pikas experience on the rocks where they're active. The third was a subsurface microrefugia hypothesis, which says the most important thing is actually the degree to which that interstitial environment or the talus environment buffers surface temperature, so the difference between surface temperature and subsurface temperature. And finally, a context-dependent hypothesis, which said, okay, microrefugia are important, but they're really only important in places where individuals are exposed to extreme climate temperatures. Otherwise, they don't really matter. So briefly on our methods, we surveyed 199 sites across about 2.2 million acres of potential pika habitat in the western part of the state, so Bridger-Teton National Forest. At a subset of these sites, we also deployed 40 paired temperature loggers that simultaneously recorded surface temperature, subsurface temperature, and by extension, the difference between the two. And this is what we found. So overall, we found quite a bit of variation in temperature within a site, which is exactly what you would expect in a highly seasonal environment. But notably, we found a lot of variation in subsurface temperature between sites, and that's what I'm showing you here. So on the x-axis is date, and on the y-axis is temperature in degrees Celsius. I want to direct your attention to this winter of 2010 and 2011, and I should note that high elevation sites are shown here in the darker black line, and low elevation sites are shown in the lighter gray line. So as you can see, high elevation sites during this winter, the temperatures, the subsurface temperatures at these sites were actually very stable and really not that cold, whereas low elevation sites were both highly variable and individuals in these sites were exposed to extremely cold temperatures. So the take-home message is that the coldest temperatures were at the lowest elevations and also the most variable conditions were at the lowest elevations. All right, you'll remember that we evaluated those 5 alternative hypotheses. I'm going to skip through all the details and just tell you that the best, far and away predictor of pika occurrence was the subsurface microrefugia variable. So essentially, how much the subsurface environment buffers individuals from surface temperatures. And when I say it was far and away the best, I mean it really was far and away the best. So this model, a univariate term for subsurface microrefugia, performed well. No other model was within sort of the competing model set as we think of it in the AIC world. And it correctly predicted 75% of both our observed presences and absences, which is pretty good performance for a model of this type. So the odds of a pika occurrence increased 18 times for each degree increase in the difference between the surface temperature and the subsurface temperature. So what we found is that microrefugia is really important to the occurrence of this climate-sensitive montane species. And indeed, microrefugia may allow species to occur in places with unfavorable, variable, or stressful conditions. However, it's important to note that microrefugia really is an imperfect solution to climate variability because a species or an individual can't shelter forever, right? You've got to find mates, you've got to eat, you've got to secure all the resources that an individual needs to truly persist at a site. So as we continue our work, we're going to look at how individuals may be able to change their behavior and balance the trade-off between exploiting microrefugia and securing the food resources that they need to survive the winter. Results of our work will inform the PICA SGCN ranking in the updated version of the State Wildlife Action Plan. In addition, we'll provide the department with enhanced understanding of climate change risks, particularly to high elevation species. With dramatic changes in both temperature and precipitation predicted by the end of the 21st century, it's important that we begin to understand the resilience of both high elevation species and other wildlife across the state. With that, I'd like to thank our partners and our funders, particularly the Wyoming Game and Fish Department, the U.S. Geological Survey, and the University of Wyoming. With that, I will take questions. Matt. That's a good question. So the question was, how can managers use these results to be able to sustain PICAs in the face of climate change? Well, I mean, it's important to note right now that there isn't really active PICA management happening on the ground. I think the species was petitioned to be listed in 2010, and that petition was in 2007, and that petition was denied in 2010, largely because of a lack of information on how the species might respond to changes. This research suggests that if there is a targeted effort to manage PICAs, I think placing those management efforts in a space where there's good microrefugia available is a great first step. In fact, I mean, maybe there would be options to supplement microrefugia if managers deem that having PICAs in a particular area is really important. So augmenting boulder size, boulder shape, availability of boulders, and particularly coupling that with things that might improve forage quality. Other questions? All right, thank you.
Our next speaker is Lindsay Sanders, who is a brand new master's student in my lab, and she'll be talking to us today about understanding mechanisms underlying increased nest predation risk of songbirds that breed among natural gas fields in western Wyoming.
Thank you, Anna. Well, as we're all well aware, natural gas development throughout the country and in Wyoming in particular has been increasing dramatically since the late 1990s, and particularly within Wyoming, a large portion of this natural gas development is taking place within the sagebrush steppe habitat. And so here you see a map of the sagebrush distribution throughout Wyoming. And you can see, so on this map, producing natural gas wells are shown in red, and wells authorized for production are shown in brown. And you can see there's a huge overlap between the sagebrush habitat and energy development throughout the state. And so this increase in energy development poses potentially pretty large implications for wildlife that are dependent on the sagebrush habitat. And these implications can range from direct habitat loss by well pad development, habitat fragmentation by roads and other associated infrastructure, changes in resource availability, such as food and habitat availability caused by, say, the introduction of invasive plants, and potentially modifications in species interactions between species that are competing for these changed or altered resources. And so one example of a potential species interaction we might see are altered relationships between predators and prey. And so when most of us think of a predator-prey relationship, we typically think of a relationship between a carnivore and an herbivore, like, say, this fox and rabbit. But it's important to remember that predator-prey relationships can be manifested at multiple scales, and predators can also include smaller omnivorous taxa that are sometimes thought of as prey themselves, such as, in this case, this squirrel depredating a songbird nest. And so my research is particularly focused on this issue of songbird nest success and nest predation in the sagebrush. And shrubland birds are some of the fastest declining species in North America. And in Wyoming, we have 3 species of sagebrush obligate songbirds, the brewer sparrow, sagebrush sparrow, and sage thrasher. And all 3 of these are listed as species of greatest conservation need by the state of Wyoming. And they're also all declining at least through portions of their range. So the Chalfoun Lab has been studying songbird nest success for these 3 species in Western Wyoming since 2008. And just to give you a little bit of background on that research, in 2008 and 2009, Gilbert and Chalfoun established this relationship between decreasing nest bird success associated with increasing well density, decreasing nest success associated with increasing well density for all 3 of these species. And they also determined that 90% of the nest failures they observed were caused by predation. So in 2011 and 2012, Heathcote and Chalfoun were able to identify this group of nest predators responsible for nest predations. And these nest predators include raptors, rodents, some larger mesocarnivores, and shrikes. But 75% of the nest predation events that they observed were caused by rodents. And they also identified some trends in increasing rodent abundance for ground squirrels and deer mice, with increasing habitat loss associated with this natural gas development. And so with these trends in rodent abundance in mind, we're left asking the question, why are we seeing these trends? Or more specifically, what is causing this increased rodent abundance around well sites? So this is the primary focus of my research, is answering this question. And we've developed a couple of hypotheses in an attempt to address this question. And the first is we're referring to as the mesopredator release hypothesis. And so this is the idea that rodent predators, such as coyotes, may be avoiding areas around energy development. And this is leading to a decreased predation threat for the rodents and allowing their populations to increase. Next, we have the food availability hypothesis. So this idea involves the reclaimed areas around the gas wells. And these areas, after disturbance, are reseeded with grasses, shrubs, and forbs in an attempt to restore their plant diversity. But these areas don't always exactly match the surrounding native sagebrush. And so this hypothesis is positing that these areas may be providing higher quality food resources for the rodents, and these areas may be able to sustain larger populations of rodents. And lastly, we have the burrowing ability hypothesis. And this is the idea that these recently tilled soils around the reclaimed areas may be less compacted than soils in the surrounding sagebrush, and they may be easier for the rodents to burrow through, so rodents may be preferentially choosing these sites for burrowing. So our study takes place in the Upper Green River Basin in western Wyoming. We have 12 study sites spread out across a gradient of well density from 0 to 15 wells per hectare at the Jonah gas field and the Pinedale anticline. And you can see this is one of those areas with high overlap of sagebrush and energy development. So in order to address these questions, we're first going to be continuing to monitor nest survival, continuing to identify nest predators, and moving forward with some more robust survey methods for monitoring small mammal abundance. And it's important for us to establish that these trends are remaining the same in this landscape, while we are also assessing potential mechanisms behind this trend in small mammal abundance. So we're also adding survey methods to address each of our study questions. And I'm just going to talk briefly about the study methods for addressing our mesopredator release hypothesis. So we're going to be setting up scent stations using motion-activated trail cameras to identify potential terrestrial rodent predators such as badgers, coyotes, and foxes. And we'll also be doing 10-minute point counts to identify potential aerial predators such as accipiters and falcons. So what do we expect to learn from this research? Well, first, we hope to solidify this previously observed relationship between nest success and small mammal abundance, and also to identify some of the mechanisms underlying this relationship. And once we have a solid understanding of that relationship, we'll be able to move forward towards implementing more targeted and effective mitigation strategies for minimizing the impacts of energy development on these bird communities. And so, for instance, if we discover that the food availability hypothesis is correct and that rodents are receiving food subsidies from these reclaimed areas, we may be able to make recommendations on potential seed mixes for the future for these reclaimed areas that more closely match the native plant community. And so with that, I'd like to thank our funders from USGS and the Wyoming Game and Fish Department and take any questions. Gabe?
So it seems like when you find support for some of these hypotheses, you'll really be able to direct manage the efforts in a critical way. So if you do find support for the predator hypothesis and the areas, what do you think are some ways to maybe lure or get predators back?
Yes, so the question was what potential management strategies we might be able to implement if we find support for the mesopredator release hypothesis. And I think that that this hypothesis in particular, there might be some large barriers to trying to direct mesocarnivores on the landscape. They have pretty large home ranges, and you know, it might be somewhat difficult to try and draw them back into energy development depending on what is keeping them away from those areas, which we don't know. But it's important to try and address all of these potential drivers behind the rodent abundance. And so we may find that the mesopredator release hypothesis is not a driver behind rodent abundance, and we'll be able to kind of check that off the list as whether it is a cause or not, and direct effort towards hypotheses that might have more critical management implications. Thank you.
Our last speaker of this session is Gabe Ariel, who is also a brand new master's student in my lab, and he has promised me that he's not going to tell any jokes in his talk.
All right, thank you, Anna. So I know what you're all thinking. Finally, an amphibian talk. So you're welcome. And I do want to mention that this is a nation blossoming project that is headed into its first field season this summer. So it's no secret that in recent decades, amphibian populations have been declining worldwide. And that's what this figure is illustrating here. So if you follow with me, we have this list of amphibian families on the left here. And on the right, we have a number of species within those families that are rapidly declining. And I want to draw your attention to this first family on the list, Bufonidae, or what is known as the true toads. And we can see that there are over 100 species of true toads rapidly declining. And if we follow this color-coded key, we can see in yellow here that about 20% of those species are declining due to habitat reduction, habitat-related causation. But what's more alarming is in red here, we can see that over 80% of those species declines are termed enigmatic, which suggests there's a lack of understanding of the underlying mechanisms that are driving these populations to decline. So as you might imagine, the boreal toad is no exception to this general trend in amphibian and true toad declines. And the boreal toad was once, or Anaxyrus boreas was once widespread throughout the western United States and western Canada, but it has declined precipitously throughout its range. For instance, if you look into Wyoming, we can see that in black here, we're outlining the boreal toad's historic range in Wyoming. And in light green, we can see that boreal toads are only occupying a subset of that historic range. And because of this, the boreal toad has been termed an NSS1 and a species of greatest conservation need in Wyoming, as defined by the 2010 SWOT. And many of the boreal toad populations in Wyoming are located in the Bridger-Teton National Forest, which is outlined here in red. And two factors that have received a lot of attention recently that may be affecting boreal toad populations on the forest are livestock grazing and the chytrid fungus. The chytrid fungus because of its global significance, and livestock grazing because it is a local prominent land use on the forest. For instance, the Upper Green River Cattle Association and other ranching associations have been grazing cattle in this area for over 100 years. And many of those summer and fall grazing pastures are located on the higher elevation allotments on the Bridger-Teton National Forest. And that summer and fall cattle activity coincides with the active season of boreal toads. And as far as chytrid fungus is a global amphibian disease that has caused high mortality rates pretty much everywhere that it's found. We can see from this map that with the red dots, we can see chytrid is very prevalent in North America. And if we look at the Bridger-Teton National Forest, we can see again with these red dots that it's also prevalent, chytrid's also prevalent on the forest. However, there hasn't been any amphibian declines on the forest attributed to chytrid. So we know that chytrid and grazing are both prevalent on the forest, but what we don't know is how grazing may individually affect boreal toad populations, and also how grazing might combine with chytrid to interact synergistically and possibly affect boreal toad populations. So our study design really rested upon finding variation in cattle grazing intensity across known boreal toad breeding sites. So this is a map of the study area. So in black here is known boreal toad breeding sites, and in purple are grazing allotments on the Bridger-Teton National Forest. And from talking with Forest Service personnel and range cons, we've established these two larger study areas that are outlined here in red. One on the eastern slope of the northern Wyoming range and one in the Upper Green River drainage. And within both of these larger study areas, from talking about with the Forest Service and the range cons about which allotments or pastures might be deferred or rested this year, which ones have higher stocking rates or lower stocking rates, we have a priori established in each of these study areas sort of a gradient of livestock grazing intensity over known boreal toad breeding sites. And within both of these study areas, we have several objectives that we'd like to address. The first one is to assess boreal toad movement and habitat use at both the micro and macro scale. And we will do this, we're going to assess movement by radio tracking boreal toads. So we'll track about 50 adult toads over 2015 and 2016. And at each relocation site, we will assess the macro and micro habitat. We also want to get at some components of fitness of these boreal toads. Specifically, we want to estimate adult survival over this gradient of livestock grazing intensity. So from 2015 to 2017, we will do a market capture study of several hundred boreal toads to get at this apparent adult survival rates. And of course, as I mentioned before, we want to get at this idea of chytrid. So what's the chytrid prevalence like on the forest, and how can we relate that back to both habitats that these toads are selecting, as well as toad survival? So while we're out there, we're also going to be swabbing for chytrid from these boreal toads and analyzing those samples via PCR. And with all of this data, locally on the Bridger-Teton National Forest, we have a better idea of the habitat use, the movement, survival, disease status of these very understudied boreal toad populations. We'll have an idea of how far these toads are moving away from the riparian zone, what types of habitat features do they need, is there a certain vegetation height that they prefer, and very importantly, we will have a better idea of the temporal and spatial overlap of cattle grazing activity and boreal toad movement through their landscape. And with all of this, we will have a better understanding of the critical resources necessary for these boreal toads populations to survive and thrive in this area. And we can provide information to the several agencies that are trying to improve management of boreal toads in Wyoming. But more broadly, Many studies that focus on amphibian declines look at a single stressor. So they'll look at how climate change or chytrid fungus or pollution affects amphibian populations. And although it may be apparent that multiple stressors may be at play in amphibian declines, most studies that look at multiple stressors tend to focus in a controlled laboratory setting, or they tend to take population data and do model simulation of that. So our hope is to provide a nice framework for future research into amphibian populations, as far as trying to provide a framework for field studies and looking at multiple stressors in the field, so we can try to improve amphibian conservation and management worldwide. And with that, this project wouldn't be possible without Wyoming Game and Fish Department funding, as well as the U.S. Forest Service and the Range Cons really helping out, and a lot of other agencies, and especially some special thanks to individuals. I want to give a shout out to Mandy Larson, because probably all of our projects wouldn't be possible without her patience and awesomeness. So with that, I'll take any questions. Right. Absolutely. So the question was, is it possible for amphibians to have chytrid or be positive for chytrid and be a carrier rather than actually contracting the disease and having a loss of either mortality or fitness because of the chytrid? And that's a great question, and the answer is yes. And what's interesting is the chytrid prevalence in the Boreal or in the Bridger-Teton National Forest is similar to that in Colorado, in the Rocky Mountain region of Colorado, except the boreal toads in Colorado have plummeted, and those plummeting of the populations have been attributed to the chytrid fungus. Whereas the prevalence is similar here, we just aren't seeing those declines as of yet. And they've actually transplanted toads from the Bridger-Teton National Forest into laboratory experiments, and they have seen mortality because of chytrid in the lab. But so we're thinking something in the environment, or something they're doing in the environment in this area might help them, sustain their populations even with this high chytrid prevalence. Yes.
So you're looking at patterns across the gradient of current gradient intensity.
Yes.
Do you have any idea that there really is a real difference in realized density on the ground in terms of unit grid and plan perhaps to introduce additional pressure maybe so you get a more gradient effect?
Yeah. So the question is, and sorry, I'm going to botch this, but is there a real, can we really establish a gradient of livestock grazing intensity on the ground, and how can we relate that back to the toad scale? And that is basically probably our biggest, has been our biggest issue thus far for this project. So a priori, we can't really establish an actual gradient of livestock grazing intensity, but from knowing which pastures might be rested and which pastures might be heavily stocked, we can get at least variation in grazing intensity. And then while we're there on the ground, we're actually going to be monitoring grazing intensity at the toad scale. So at each relocation, we'll have our habitat metrics that we're assessing, also grazing metrics. And some of the fellow folks in the ranching organizations have offered to actually manipulate. So we're still working on that, but they've actually offered to manipulate their pastures and rest some and really heavily stock some and keep them in these confined areas. But I think to get more at your question is each individual toad, regardless of if they come from similar areas, are going to be experiencing a different grazing intensity as they move. So we'll treat the individual toad as a replicate as they move through the habitat. All right, thanks.
are now segueing into the final series of talks, and all of these individuals are members of Annika Walters' lab. I should have mentioned before, if I attributed Gabe just to my lab, Gabriel is actually in both the Chalfoun and Walters lab. So the first talk in this final session will be by Lindsay Sapella, who'll be talking about determining salmonid natal stream of origin and movement in the upper North Platte River drainage using strontium isotopes and otoliths.
Thanks, Anna. Thanks for sticking around for this last session as we dive into the aquatics realm. We'll start our swim off in the upper North Platte River, looking at natal streams and movement of salmonids. First, just a little bit about the upper North Platte River. It's located just west of us in southern Carbon County, but the majority of my research, well, all of my research actually, will be focused on the North Platte River from Saratoga south to the Colorado border. Can you go ahead and start that slideshow? Thanks. So it'd be located from Saratoga south to the Colorado border along the North Platte and associated tributaries. We'll give it just a second. Great. And a couple things about the upper North Platte River. It supports a nationally recognized wild trout fishery with 76 miles of the North Platte River and 11 miles of the Encampment River being classified as blue ribbon streams. The productivity of this fishery is largely dependent, or is thought to be largely dependent, on access to spawning tributaries, although which tributaries and the extent these tributaries are used is unknown to managers, which is a pretty big concern given current and future threats to the basin. This basin could be facing changes to water temperature, altered flow regimes, water quality degradation and fragmentation due to water diversion projects, energy development, and tree mortality due to the mountain pine beetle. So understanding which tributaries are being used is going to be really important for creating management plans, which is where my project comes in. The primary objective of this project is to determine where these fish are coming from and where they're going throughout their life. To do this, we will utilize strontium isotopes found within a fish otoliths, track those isotopes through time, and match them back to isotopes found within the watershed. But before we can do any of this, we have to construct a strontium map. So we have to identify which regions in the area have these strontium signatures. Additionally, we have to look at the temporal variability of strontium isotopes throughout the region. So first, we might be asking, what is strontium, or how do we even use this? It's a chemical element that is found naturally in the earth. It's based on the diversity of rock types, ages, and how they weather. This creates the variation in strontium isotopes across the landscape. As water flows over this bedrock, the isotope gets incorporated into the water, and then as fish swim through regions of water, they incorporate the signature into their isotopes. Additionally, strontium originates from bedrock material, and it maintains the signature of the parent material, making it pretty stable over time and a viable option to look back into a fish's history to determine those ratios. And so one of the major successes of strontium projects is understanding the underlying geology of the watersheds. So going back to our watershed, we can overlay a map of the geology, and we see it's pretty diverse. A lot of these tributaries have different regions. So by selecting sites across this region, we can determine the ratios throughout the region, and then again, match those ratios we found in otoliths back to our sample sites. And to build this map, we'll be collecting 2 juveniles at each site. This will enable us to get a strontium ratio for each site that kind of incorporates the overall strontium value of the region. So as a fish swims through microhabitat, it's kind of picking up different microsignatures, getting us a better average of the area. And then additionally, as you move upstream into the headwaters, the ratio might vary, and so we'll select sites from downstream to upstream to look at that longitudinal variability. And then the second part of understanding strontium in a watershed is looking at the temporal variability through time. And to do this, we'll collect water samples multiple times throughout the year, and then we'll also collect water samples over the course of several years. And now we already have data from 2009 and 2014 for several sites throughout the watershed. And as you can see, it's, it's pretty stable as you move across sites. Some sites like 14 through 16 are really good. There's actually 2 dots on the same strontium ratio. And so I should have said on this, along the x-axis we have site number, and then along the y-axis is actually our strontium values. And so once we have a good understanding of how strontium varies throughout the watershed, we can start to answer the exciting questions of where fish are coming from in our watershed. And to do this, we're going to collect adult salmon otoliths from the main stem of the North Platte River. We'll then laser ablate across each otolith, collecting those strontium values and match the longitudinal otolith signature back to the natal regions of our strontium map that we've created. And so here is a graph of what this data looks like. Along the x-axis, we have the point series, which is just basically as the laser ablates the otolith across it, it's collecting a series of data, which is plotted along the y-axis. That black line is a moving average of that point cloud. And so just from a quick look, it's really easily to distinguish that we have a natal region and we have a residential region. And so once our strontium map is created, we can actually say these signatures match this area of our watershed, and then this area matches these. And so getting this natal, being able to track the natal region and the residential region allows managers to focus current and future restoration efforts based on tributary use. Currently, there's a large amount of flooding going into this watershed, and it's mainly focused on 3 primary tributaries that are thought to be useful for production, but there's very little information to back this up. And so by being able to say which tributaries are being used, we can focus current and future restoration activities, improving long-term monitoring efforts in restoration, and then which will lead to maintenance of the overall success and longevity of the national wild trout fishery. So with that, I would like to thank our funding agency, Wyoming Game and Fish, and a few individuals who have helped immensely with the planning of this project already: Steve Gale, Mark Smith, Amanda Larson, and Diego Fernandez. Thanks. Questions? Yeah. We will. The North Platte actually has a very distinct signature from all of the tributaries. And so we'll also have part of our map will include the North Platte River. And so if we get a signature that matches the North Platte River in a natal region, we can say that it was spawned in the North Platte. Did you have another question? Yeah. They are not currently stocking trout, so stocking ended in the 80s. Fish might be migrating up from the downstream reservoir, although I'm pretty sure they're blocked for upstream migration. It's mostly differences in flow and surface runoff versus groundwater runoff, so it varies between snowpack years. And it's pretty minimal. We have one site that it's really big, and we're looking into what's causing that big variation. But for the most part, it's just kind of year-to-year fluctuations based on. They're actually bigger drainages. So it's incorporating different signatures. So like small changes in surface versus groundwater runoff don't have as big of an impact. Thanks.
Just as a quick reminder to speakers, do remember to repeat the audience questions for our YouTube watchers, please. Our next speaker is Richard Walker, who I believe is a PhD student in Annika's lab. He'll be speaking about ecological responses to stressors in headwater streams of the Wyoming Range.
Thanks for that introduction, Anna. as Anna said, I'm a student of Annika Walters. This is my second semester as a PhD student under her. And today's talk is really going to be focused on giving you guys an idea of what discussions Annika and I have been having as far as the directions we're going to take the work that Carlin kind of started. And Carlin, I would add, did a really good job setting this experiment up and going through this. And so the ultimate goal of my dissertation is kind of improve upon what he did, add more to really get at some of the underlying mechanisms in the patterns that we're seeing in our fish populations in these streams. And so first off, I would like to start by defining what a stressor is. And I'm going to use the definition that was coined by a group out of New Zealand. And for the most part, this is a generally accepted definition. And this is that a stressor is a variable, usually of anthropogenic origin, that exceeds its normal range of variation. And this can have negative impacts at the individual level, as well as populations and communities. And we have evidence showing that we see changes at the ecosystem level as well. Now, I say for the most part, I would like to use this definition. I would also argue that there are natural stressors or disturbances in these systems that can also cause negative effects on these populations and communities. And in particular, our headwater streams, small headwater streams that I work in, floods and droughts or variability in hydrology across years can be very important. Now, most of the research up until the late 1990s and early 2000s had really focused on single stressors and how they affected ecological change, usually at the population and community level. Now, as most of you are aware, and Gabe alluded to earlier, that most ecosystems, there are very few ecosystems, if any, remaining that are affected by a single stressor. And we're just now on the forefront of understanding how all of these stressors interact to affect ecological change. The picture here illustrates the energy development in some of our areas that we work. And I just want to point out that this picture illustrates that this one anthropogenic activity can have multiple stressors associated with it. As you can see, all of the surface disturbances, we see lots of well pads, right-of-ways, and roads that are going to potentially increase sediment load to the streams. This is also going to reduce the riparian zone and move the stream here. So we see a reduction in riparian zone, riparian cover, as well as decreases in water quality in some of these areas. And now as managers and conservationists, it's important for us to understand what stressors are involved or at play, how they may be interacting, and then also at what level of ecological organization are they going to be having impacts. I would also like to add, on top of all of this activity, we have cattle grazing, which is going to make for a very challenging and difficult task to kind of tease apart these different stressors. Now, I kind of keep mentioning different levels of biological organization, and for that, I would like to refer to this diagram from the Biological Indicators of Stress in Fish. It was published by Adams in 1992. And real quick, describe it here. The x-axis, as you can see, is kind of the relative time frame with which a response variable is going to occur following a stressor. On the y-axis, we have the level of ecological or biological relevance, from high at the very bottom to low. I know it seems odd, but it's the way the diagram was in the book. And if we plot the different categories that Adams described, we see that there's a variety of different biological responses that we could measure. Now, again, I'm talking about the axis here. Oftentimes we see the responses that occur within seconds to minutes, the shorter time frame, that are less ecologically relevant or biologically relevant, to responses that occur to populations or communities. And these are more generally the long-term responses that we tend to measure. And now, as conservationists and managers, we tend to focus here at the population and community level. But if we're seeing negative changes at this longer-term scale, it may be too late to really implement the proper management practices that are actually going to halt or reverse those negative impacts. And so one of the ultimate goals of my dissertation is to kind of sample a suite of response variables across this gradient that are going to hopefully allow me to understand the mechanisms that may be driving the changes in populations that we're seeing. And so I'm going to look at a suite of responses looking at physiology and changes to immunology, growth and condition, and then we're going to continue adding on to what Carlin did, looking at the changes in populations and communities. So the ultimate goals of my dissertation, kind of 4 general chapters that we've been discussing, Annika and I. And the first one is looking at some of the more basal responses. So those responses that occur over a shorter time frame, looking at the physiological and immunological responses of mountain sucker and mottled sculpin. And this is going to be a collaborative effort with a group from Utah State University. They've been doing a lot of this work with lizards and urbanization in Arizona. And so we're going to be collaborating, looking at this for our fishes in these streams. And with this, we're going to be kind of looking at some of the stressors that may be associated with energy development. So potentially increases in salinity, increases in sedimentation, and kind of looking at how those may be affecting the physiology and immunology. Second chapter, we're going to be adding on to Carlin's work, as I said, and we're going to be looking at changes in the fish population dynamics. So we're going to be actually reducing the number of fish sites that he's been sampling in our streams. And I'll show you in a map in a moment. And actually, again, focusing some more of those mechanisms underlying it. The third chapter, we're going to be kind of focusing on the resource quality and quantity. So this, in a couple of weeks, I'm going to go out and put out tiles. This is going to allow us to look at the resources, food that's available for the mountain sucker. So the quality and quantity of that, as well as for the mountain sucker and cutthroat trout, we're going to be looking at the aquatic invertebrates as well as the terrestrial subsidies falling into the stream and seeing if we see differences there. For the fourth chapter, which we haven't really discussed a whole lot, this is going to be more in the long term. We're going to be looking at manipulative studies, either in the lab or the field. We haven't quite decided to actually manipulate these different stressors to see how they affect ecological change across these different levels of ecological organization. So to jump to our study streams, I think most of you again are aware of Carlin's work. These streams are on the eastern flank of the Wyoming Range, just to the west of Big Piney. Let's take a closer look at our study streams. And I have outlined in orange or yellow, whatever color that shows up to you guys. It is showing the Dry Piney watershed, which is our high impact watershed. The outline in blue is our South Beaver reference streams, to kind of orient you guys. And as you can see, these red stars represent well locations within our study area. And there's a gradient from south to north where we see lower energy development to the north. And now this particular area is important, especially our reference streams, because it holds one of the few remaining genetically pure populations of cutthroat trout in the state of Wyoming. And it's actually proposed to have about 800 more wells at the moment to be drilled in this area. So it's going to be very important that we continue to monitor these streams. Let's do a little ground truthing. I could show you a bunch of graphs as far as the data that Carlin had collected, as far as riparian cover, substrates, habitat availability, but I figured I'd show you a few pictures. You would like that a little better. So the first set of pictures is going to be representative of our high impact or high energy development sites. And as you can see, there's a lack of riparian cover, very little, if any, riparian cover up next to the stream. We see a very uniform channel, so basically a uniform run going all the way through. And this picture here I put up here, you can see all the sediment that's kind of accumulated. If you walk up to this site, and a lot of the sites in this area, in the stream, you stick your hand down and you stick your hand through a foot of fine sediments, and you get to the nice, beautiful cobble gravel substrates that trout and sculpin like to spawn and eat in. So high impact sites here. In turn, our reference sites, reference reaches, we see lots of riparian cover, almost too much in some places. We see a diversity of substrates, gravels and cobbles, lots of pocket water. Also, we have a lot of beavers in these watersheds, and so that increases pool habitat as well. And so I want you to step back and think about, picture yourself as a fish or a macroinvertebrate in one of these streams. Which stream would you rather live in, and which one do you think has the best management practices that are implemented in those watersheds? And so to kind of bring this back to the importance of management, again, it's very important for us to understand what stressors are at play, whether it be energy development, these anthropogenic stressors, cattle grazing, or natural stressor, the variability in hydrology, how those stressors may be interacting to affect ecological change. And then again, at what biological level is this going to give us more accurate information in order to implement management strategies that are going to halt or reverse those negative impacts. And as far as the best management practices that are currently being done, I think we're doing a pretty good job. Maybe need some improvement as far as those management practices that are going to reduce sediment load to the streams. They're going to reduce, we want to increase riparian cover in some of these areas that have been lost, such as the picture here. And also the water quality. That's a big issue in this area. As far as the grazing management and current practices that are going, I think the ranchers are doing a really good job pushing the cattle off the streams. Early in the day, they'll come out and do this, but it's not to say I don't have information as far as legacy effects of cattle grazing and how that may impact current populations of fishes. And so with that, I'd like to thank our funders, the Wyoming Landscape Conservation Initiative. I've talked with a couple of people from the Wyoming Game and Fish, and some details on some sampling, and then especially the landowners, Jay and Sandy McGinnis, for letting us access their property. You know, that was very vague and as far as what I'm going to be doing, but if you have any questions, I can answer those.
All right, our next speaker is Zach Underwood, who will be speaking about the effects of water development on the connectivity of burbot in the upper Wind River Basin.
All right, thank you. Thank you all for the opportunity to share my master's research with you today. And I am finally at the point where I have all my data collected for this project, so you get to see kind of the full realm of what we found. So burbot within the Wind River drainage are a pretty unique species because this drainage marks the southwestern extent of their native range in North America. And it's the only area within Wyoming that they're native to. And they're considered at risk in Wyoming. So conservation of this species is a high priority. The drainage is comprised of several natural source populations highlighted here in green. And at the Wind River Diversion Dam pictured here, water is diverted from the Wind River into an irrigation network highlighted in brown. And there are there are populations of burbot within this network that are potentially sink populations for those natural source populations. Specifically, these populations are Pilot Butte Reservoir, which has year-round burbot, and then the outlet of Pilot Butte Reservoir has burbot for most of the year and potentially year-round to some degree, but specifically in the small pool pictured here. And at the end of the irrigation season, burbot within this outlet pool can reach numbers over 2,000 fish. So this represents a potential very large-scale level of entrainment into the irrigation network of burbot that are essentially lost from the system. So the question that kind of spurred my project is, where are these fish coming from? And kind of the main expected source was Bull Lake Reservoir. And that's because this is a large reservoir with a large burbot population. It also has a bottom draw dam, and the flow regime below this dam is very variable, with extremely high releases of water at times. And so it's thought that small age 0 burbot can potentially be washed out of the reservoir in large numbers. So my research objectives are first to identify what the source population is of those burbot entrained in Pilot Butte Canal below Pilot Butte Reservoir, and to see whether or not Bull Lake is in fact the main source for those burbot. And additionally, this system offers a very unique setting to look at how source sink dynamics of a fish species can be affected by water development and irrigation. So to answer those questions, I used 3 different kind of overall studies. Outmigration directly below Bull Lake to see how the flow regime and different factors influence outmigration, and also to see what degree of outmigration is occurring below this lake. And that was primarily a netting and a mark recapture study. Then I also used otolith microchemistry, looking at strontium ratios like Lindsay described, to look at where individual fish entrained in Pilot Butte Canal were originating from. And then lastly, I used a genetic approach to look at the integrated results of outmigration and movement throughout the system on a population level at the various populations in the basin. So I'm just going to jump straight into results. And what I have here are some of the results from the netting study. And what we saw was actually a very low catch rate. And we sampled fairly extensively in 2 years, 2013, 2014, from May through October. And we really feel that these low catch rates are indicative of a fairly low outmigration rate. In 2013, we only caught 40 individual fish. In 2014, we only caught 60 fish. One difference we did notice was that in 2014, as these figures show, we caught significantly more small age 0 fish. So some condition that was occurring drove a greater outmigration rate of these age 0 fish, which are the expected mass outmigrants. However, we didn't really see any strong ties one way or another with flow or temperature or other environmental or dam operation conditions. So looking at the otolith microchemistry results, here is a figure showing strontium ratios on the x-axis for each of the different sites. And in green, we have our potential source sites. And as you can see, there's a fairly strong difference between the upper watershed sites, Torrey Lake, Upper Dinwiddie, and Lower Dinwiddie, that we sampled compared to Bull Lake. So the strontium ratios do vary, which allows us to see that while we did collect 2 fish in Pilot Butte Canal that match with the Bull Lake strontium ratio, the vast majority of the Pilot Butte Canal fish came directly from Pilot Butte Reservoir, meaning that they were spawned and spent their entire life in Pilot Butte Reservoir until ending up in the canal. So we know there's some degree of movement from Bull Lake to the canal, but what is the effect of this over time? So this figure here shows the genetic differentiation between populations plotted throughout the basin. And first of all, what we see is that there are major branches of this genetic tree that indicate a genetic differentiation between the upper and lower basin, as well as a genetic differentiation between populations on unique tributaries. So there's strong genetic differentiation within the basin. And when we look at our entrained fish population within Pilot Butte Canal, we see that fish from the canal are on the same branch of the tree as the Pilot Butte Reservoir fish. So we know that the Pilot Butte Canal fish are coming directly from Pilot Butte Reservoir. And what we can also tell is that genetic differentiation has occurred between the irrigation populations and the natural populations. So this is a unique population of fish that is self-sustaining and contributing to the outmigration that we've been seeing into the canal system. So what this means for management and future directions with burbot is that Bull Lake really is not the contemporary source of these entrained burbot as was expected. Therefore, at this point, there's really not an urgent need for mitigation measures. There's been discussion of implementing fish screens, that sort of nature. And it seems like there's not the evidence based on our research to support that kind of measure. We also see that really source sink dynamics are not occurring between the natural populations and the irrigation populations. In fact, we have a unique population of burbot that is developed within the irrigation network, which is a pretty interesting finding. Just that in some cases, water development can in fact increase genetic diversity in a region. So one action that management could consider in the region is to potentially salvage burbot from the canal, which, like I said, are lost from the population altogether once the canal dries up, and return them back to Pilot Butte Reservoir, which might have benefits such as having a higher density of burbot within the reservoir, which can make an artificial population a destination population for burbot angling in the region and maybe relieve some pressure on natural populations. So with that, I would just like to thank my funding partners, primarily Wyoming Game and Fish and USGS, and all my collaborators in the field and in the lab with this variety of different techniques that I could not learn entirely all myself. So very many people helped out a lot. And with that, I'd like to take any questions. Gabe?
So you said that the genetic differentiation between the but among the population, within the two populations, are they pretty homogeneous, or are they going to have enough genetic variability within them?
So the question was within the irrigation populations, we saw genetic differentiation from the other populations, but within the populations, is there enough genetic diversity to sustain themselves without genetic consequences? And didn't really look at that specifically. The population is, it's been around for a number of decades, since the 30s or 40s probably, and there aren't any apparent consequences of kind of having a small founder effect going on. So it seems like it's doing okay. We didn't really look at that specifically, though. Genetic variability and kind of the genetic drift that's occurred has been fairly low. So there's not a lot of genetic variability in that population. Thank you.
Okay, our next speaker is Caitlin Peterson. The title of her talk is Proposed Revisions to Wyoming Water Quality Rules and Regulations, Aquatic Life Use Guilds, and Temperature Criteria.
Thanks, Anna. All right, so I'm working with the Wyoming Department of Environmental Quality to evaluate the existing surface water temperature regulations, specifically as they relate to bodies of water which have the potential to support aquatic life. We are hoping through my project to propose any needed revisions and consider any potential areas of improvement in these surface water temperature standards. To give you a brief overview of where I'm going to go with this presentation, so I'm first going to just really quickly consider the role that temperature plays in aquatic ecology and why temperature management is a really crucial part of fisheries management. Then I'm going to look at the existing surface water temperature aquatic life regulations here in Wyoming. And then finally, I'm going to consider some of the concerns that we've highlighted with these regulations, and then also look at the proposed improvements that we hope to develop throughout my project. All right, so as a really brief overview, of course, temperature plays a really important role when looking at the ecology of fish populations. So looking at this really simplified figure that I've put on the slide, it's clear that all fish species have an optimal temperature at which their different physiological rates are optimized. So that's things like their growth rate, their reproduction, their metabolism. Once you get outside of that optimal temperature, those rates begin to drop off. Eventually, they reach a point which is lethal to the fish, where the fish can't survive at all. That's that fish's acute temperature limit, where it experiences mortality. So before we get to that point, however, you can see that outside of that optimal temperature, those rates begin declining. And at some point, we have a rate where a population is not sustainable. We're not seeing that individual fish mortality, but the growth rate, the rates of reproduction, and so on are so decreased that a population can't be supported. So we could consider that a chronic or sublethal limit to fish distribution on the landscape. So it's really important to consider this in management because humans do a lot of things which are going to have an impact on the temperature of different bodies of water. I've listed here just a few of the common ones that we are experiencing in Wyoming and throughout the world, really. In most cases, anthropogenic effects on water temperature are going to have a warming effect rather than a cooling effect. So for the most part, that's what temperature standards consider, and that's what I'm going to be considering in my project. So to give you a really brief overview now of how the Wyoming surface water temperature standards apply to aquatic life bodies of water. They begin by looking at the actual species of fish that we're finding in a given body of water. So Wyoming has chosen to divide fish species into two different thermal guilds, we call them. That's cold water fish and warm water fish. And these guild classifications are developed based upon standardized laboratory tests of fish thermal tolerances. So once we have these fish split into guilds, dividing bodies of water in the state into cold or warm water is done based upon a simple presence or absence survey of the fish species present in that water. From that point, different standards are applied to bodies of water based upon the species present. If there are cold water species present or the water is deemed to have the potential to support cold water species, the following regulations that are listed here apply. That means that these temperatures are not, or these waters are not supposed to exceed 20 degrees Celsius in temperature, and that temperature should not increase by more than 1.1 degrees Celsius above the ambient temperature. And then there are very similar regulations for warm water, except substitute in 30 degrees Celsius and 2.2 degrees Celsius. So these are the regulations as they stand right now. I'm going to leave the cold water standards in the bottom left corner of the screen there for you to use as a reference as I talk about some of the concerns that we've highlighted with this existing system. So the main one I've listed on the top is thermal guild specificity. So this division of fish into only two different thermal guilds is a little bit problematic in some ways. I've illustrated that here with this cartoon. So you see here two different cold water species of fish, cutthroat trout and brown trout, indicating where they tend to live on the landscape. Both cutthroat and brown trout are cold water fish. However, we tend to find brown trout living in these lower elevation plain streams and cutthroat trout living in higher elevation, even colder water streams. So cutthroat trout do have a much colder thermal requirement than brown trout do. What's important to think about in this figure is that because temperature standards as they're applied to water based on a presence-absence survey of fish species present in that water, both these lower elevation streams where you're seeing the brown trout and the higher elevation streams are going to be classified as cold water and held to those standards that I just described to you. Now, because these temperature standards are developed to be protective of the most sensitive species within the thermal guild, the cold water thermal guild is defined to be protective of something with as cold of requirements as cutthroat trout. Now, brown trout could live in much warmer waters than cutthroat trout, and it's very likely that this lower elevation stream indicated here was never cold enough to support cutthroat, and regardless, the habitat type is not quite right to support cutthroat. However, because of the way the regulations are written into law right now, Wyoming is kind of bound to monitor this lower elevation stream and hold it to the same standard as a higher elevation stream that you'd find cutthroat in, because they're both considered cold water. So if the guilds were more narrowly defined, if we could differentiate in the regulations between a really sensitive species like cutthroat and a moderately sensitive species like brown trout, we wouldn't be encountering this problem, and we wouldn't have to be focusing remediation efforts on these lower elevation streams that in all likelihood don't really need remediation. So to touch on those other two concerns that we've highlighted, we also see that our temperature standard as it is right now is based upon a daily maximum temperature. Water cannot exceed 20 degrees Celsius as an instantaneous measurement. Now the EPA recommends that states, in addition to an instantaneous measurement like this, apply a more chronic standard, such as a maximum weekly average temperature, in order to protect fish from those sublethal effects that could limit population distribution, but don't necessarily cause individual fish mortality. And finally, we noticed that using the language of ambient temperature in the standard is a little bit risky, because when we're looking at any waters that might already be impaired, using the ambient temperature as a baseline for remediation might not be the best approach. So as follows, here are our management proposals. Throughout my project, we're hoping to increase the number of thermal guilds to propose a classification system for fish that includes 3, 4, or maybe even 5 different guilds to differentiate between very sensitive cold water species, more moderate species, and then of course warm water species. And we hope to do this by first reevaluating individual species thermal requirements, and then thinking about statistical ways to split these fish into guilds of other species with similar requirements. Then we want to define each guild with both acute and chronic criteria as recommended by the EPA. So finally, for management implications, these 2 changes that we propose will hopefully solve most of the initial concerns that we highlighted. Of course, increasing the number of thermal guilds will solve that problem of thermal guild specificity. Adding a chronic criterion in addition to the currently existing acute criterion will allow us to be in line with that EPA recommendation. And then increasing the narrowness of the thermal guilds should take away some of the necessity for that maximum increase provision, shouldn't make it as necessary to refer to the ambient temperature in our standards. So with that, I'd like to thank all of my funders and contributors for this project, and I'd be happy to take any questions. Cool, thanks.
Okay, so our very last but not least presentation of the day is by Randy Stewart, Dr. Randy Stewart, who's a postdoc in Annika's lab. And he's been doing some pretty comprehensive and impressive modeling efforts for fishes and other aquatic critters in Wyoming.
Well, thank you for the introduction. So my project is looking to identify these native aquatic management areas that hopefully Game and Fish can set aside to protect some of our aquatic related species, that being in terms of fishes, as well as mussels, amphibians, and more of your aquatic related reptiles. So in order to do this, we have 2 overall objectives. The first objective is to develop species distribution models. We're doing this to evaluate factors that potentially could be driving species distributions throughout much of Wyoming. I'm not speaking too much on this objective given the nature of this talk, but it's important to mention because without completing the first objective, we cannot complete the second objective, which is what I'll be presenting today. And that is to identify these aquatic management areas so that we can sit down with Game and Fish like we've been doing and evaluating the various priority rankings so we can come up with some sort of combinations that might work best for them given their management strategy for this project. Now this is important because many of our freshwater ecosystems are imperiled. The projected mean future extinction rates for North American freshwater animals is 5 times higher than that in the terrestrial animals. And this is due to the synergistic effects of human alterations. And this is related to the fact that streams are inherently nested within the landscape. So therefore factors that influence the surrounding landscape will then eventually influence the stream itself. And this is due to factors like hydrology alterations, also create habitat fragmentations, pollution, land use, whether it be associated with residential development, agriculture activities, including grazing, and of course an emerging threat like oil and gas well development. All of these factors have led to some sort of population declines, especially for many of our Great Plains fishes that we have here in Wyoming. Now, back in 2001, Wyoming Game and Fish drafted the Strategic Habitat Plan with the ultimate goal of protecting these high priority habitats, because without the habitats, you no longer have the species. So therefore, protecting these habitats will allow them to maintain or at least conserve some of these terrestrial and aquatic organisms for the future. And this project rather is really related to goal number 1, which is identifying these high priority habitats so that they can implement some conservation and management strategies to conserve these aquatic species. And this is based on some sort of these habitats, or in our case, watersheds, having some sort of ecological or biological value. In our case, that's related to the types of species, whether they're rare or they're common, and their occurrence levels within a watershed. So once we're able to identify these areas, we can now start addressing these habitat issues related toward maintenance or enhancements. to help conserve these species. So we're following this, rather model-based framework. This is a very model-intensive project in which we're using multi-species collections for fishes, mussels, and then also here recently amphibians and reptiles. And then we're relating their occurrences to these landscape scale factors so that we can develop species distribution models. In order to do this, we're in an efficient technique. We're using these multi-species Bayesian mixture models. Not to go into too details there, but all we're able to do there is to account for imperfect detection. By accounting for imperfect detection, we're able to correct for the inability to effectively sample a species. In multi-species, we're assuming some sort of exchangeability among the parameter estimates. We're assuming a likeness that we can estimate the parameter estimates for all species at once, with fishes and mussels being separate, if you can distinguish on the figure there. So we're developing these species distribution models to determine how occupancy relates to these landscape scale factors so we can develop these species distribution maps from these models. We can then use these species distribution maps for fishes and mussels and incorporate them into an additional modeling software called zonation. What this is doing is it's prioritizing these watersheds based on what I said earlier, some sort of ecological or biological value, the types of species, whether they're rare, they're common, and also considers their occurrence levels, so that we can now take these results from, like the north-south plaid drainage here, looking at these color codings, red being the best overall, yellow being the top 25%, white, we don't really care too much for. And then basically sit down and evaluate these priority rankings with game and fish like we've been doing so that we can discuss the benefits, the disadvantages, the threats, so that we can make a recommendation based on some sort of subset from the combinations of these top 25% of these watersheds. So getting into some of the results for the fish, at least looking at the north-south platte drainage, we see that for most of the time for these fishes, the lower portions of some of our major rivers, such as the Laramie River, the North Platte, and Horse Creek, being ranked out as important. We see this is a common theme for the other super drainage they're reporting from. Since we're also using two different types of modeling approaches in terms of species distribution models and then coupling that with zonation, it'd be nice to know if these results somewhat align with belief. So looking at the best overall ranking watershed, which is Wheatland Creek of the Laramie River located by this box, we see that game and fish, as well as some of the master student projects that we are using data from to develop these models, that we've encountered 20 species, which is the most of any watershed within this super drainage, as well as the others that I'm presenting earlier. So it is nice to see that zonation in these models are performing as expected based on belief and on-the-ground field experiences. So we've completed these exercises for native fish throughout much of Wyoming, and we've also recently completed this for native mussels. So not to really compare the exact or the specific watersheds in terms of native fish and mussels, but just kind of giving you a general overview in terms of any type of overlap between the two. Maybe we can manage fish, and then also that also encompasses mussels in terms of an umbrella type of approach. We see that for the Bighorn River drainage, the Nowood River and the lower portion of the Bighorn River has ranked out being as rather high for native fishes. And when you compare that to mussels, you're seeing that very similar. So you're seeing a lot of overlap with the Bighorn River drainage. When you move one watershed over, kind of this triangle, with the Powder Tongue system, you see the Powder River system, most of those watersheds is ranked out fairly high in terms of native fish management, but not so much for mussels. So we do see that there is a moderate amount of overlap when you start really comparing the watersheds that have ranked out high for mussels as well as fishes, but there is still a little bit of variability. So it remains to be seen when we incorporate amphibians and reptiles into this mix, whether or not this overlap continues to be as strong as what it is at the current time. So the future directions, we're in the middle of developing species distribution models for amphibians and reptiles. When it's all said and done, we should have species distribution maps for 79 native and non-native aquatic species. That being said, we should also have identified priority management areas, not only just for fish, mussels, but also for these guys here that I'm presenting with amphibians and reptiles, so that potentially we can come up with some sort of combination that benefits all of these aquatic-related groups in terms of management in the future. And with that, I would like to thank a few of the individuals in here, Dave Zaft and Mark Smith with the Cheyenne office, as well as many of the other individuals that work in the Laramie, Casper, Sheridan, and Cody crews that have met with me on several occasions and will continue meet with me, I'm sure, as this project continues to move forward. So thank you very much. And I'll take any questions. Hey, Matt.
Yeah. Can you tell us a little more about how
Well, right now we're just trying to identify watersheds that are important for fishes, and then if we can get if the data is good enough for mussels, amphibians, and reptiles, and then from there we're going to pitch them some comment that they potentially could be using to kind of focus their efforts in terms of native fish in the future. In terms of implementing a sort of plan, I can't answer that question. That's up to Mark and Dave. Yeah, thank you. I appreciate it.
Before we adjourn, I just wanted us to give one final round of applause to our students and postdocs this morning. I think they did a really great job representing the work that we have going on in the unit. And thank you for being so good with your time. It made our jobs easier. And also, of course, thank you to our cooperators and collaborators for your support and interest.